Objective of this video is to demonstrate the approaches of using public blockchain applications like Augur and Digix. Before we start understanding public blockchain applications like Augur and Digix, we need to understand some essential capabilities of blockchain. Blockchain provides increased capacity, and this is one of the very important features about blockchain technology. Because of the reason that there are many different systems working together, and they all will provide great computing power than few of the devices. For example, we can have increased capacity in a project which contains various computing capabilities of all the computers in the network. So by utilizing capability of all the computers in the network, blockchain provides increased capabilities. Security is one of the concern, and blockchain technology commits better security, because so far there has been not a single instance where blockchain applications have shut down the system. It is only possible because you have multiple backups and you have provision of ensuring that systems are never shut down. Even the highest level of financial systems sometimes may be hacked. Bitcoin, which is one of the blockchain technology, has proved its capability by being never hacked. This is the reason why blockchain network is secured by a number of computers called nodes. And these nodes takes responsibility of confirming the transaction of the network. Third important feature is immutability. Data may change. One of the important essential feature that blockchain provides is it keeps your ledger data immutable. Any database which is centralized is typically subject to be hacked, and third-party interventions may be there in the database. But blockchain technologies like Bitcoin and others keeps its ledger in a way where it never changes. In order to ensure that ledgers are secure from changes, there is internal algorithm which has been worked out. Faster settlement. We had experience of traditional banking system where settlements were quite slow. One of the reasons why banking institutions need to upgrade the banking system is because of settlement. And blockchain provides capability of settling the money transferred at really fast speed, which ultimately takes responsibility of saving lots of time and money for the parties which are involved in those transfers. Blockchain also adopts decentralized system. When we say decentralized system, it provides power to store all the assets in a network, which can be accessed by using internet. You have an asset which can be anything like contract, a document, etc. Though this owner has direct control over the account by means of key that is linked to the account, which gives the owner a power to transfer his asset to anyone he wants. Blockchain technology has proved to be really effective tool for decentralizing the web. Minting. Basically, there are various ways of minting, and the problem of manipulation can be solved by blockchain. Blockchain takes responsibility of generating confidence in the user. Irrespective of place and the provider, blockchain internally takes responsibility of generating sufficient confidence in the user by taking sophisticated mechanism of avoiding any hack. So the role of miner in case of minting is to create a block. And these blocks are secure and they are immutable. No one can change it, which obviously increases the confidence of the user. There are various participants. For example, in Hyperledger blockchain network, you'll find regulator, you'll find blockchain network developers who will take responsibility of creating the network. Then we have traditional data sources for storage. We can also go and use Couchbase. Then you have blockchain users. All these different components are traditionally powered by traditional processing platforms and also certificate authority. Now, one of the important elements of blockchain technology is smart contracts. Smart contract is something similar to physical contract, which is there in world among two different parties, but it's digital. And smart contracts are represented by small computer programs which are stored inside blockchain. To be very specific, a smart contract is just a piece of software that stores rules for negotiating the terms of an agreement, automatically verifying fulfillment, and then execute the agreement term. It is embedded with if this then that code, which is used in order to represent rule. There are various different usage of smart contracts. For example, financial derivatives, insurance premiums, different property laws, crowdfunding agreement, all these can be executed using smart contracts. There are various instances where you'll find smart contract playing important role in terms of building a proper channelized agreement, and those implementations are frequently seen in healthcare domain and also in government sector. Now, for example, assume that you want to sell a car. So you will have two different parties, seller and buyer. There will be an exchange which will take responsibility of matching the buyer with the seller. And this particular exchange will be digitized. In order to ensure that there is proper communication between seller and buyer and terms and agreements are clear as per laws, you will be having smart contract. Finally, digitized currency can play important role in order to ensure that it is 100% digitized contract execution. Now, there are two interesting public blockchain implementations. One is Augur and second is Digix. Augur is a decentralized predictable market platform which is managed by Oracle, and it is built on Ethereum blockchain. It also allows anyone to create a prediction market, and it internally uses proof of asset protocol. Augur can be used in order to create prediction markets which are denominated in terms of currency on Ethereum implementation. Now, when it comes to Digix, it provides a transparent, auditable, and secure protocol. Typically, Digix tokenizes gold on Ethereum. It leverages all the distributed ledger capability for its immutability, auditability by applying precious physical assets. It provides POA protocol, which is utilized by Ethereum, and also IPFS, which is interplanetary file system. Objective of IPFS is to track an asset through its chain of custody. In other words, Digix provides efficient approach of applying IPFS, which permanently stores document and also facilitates in creation of transferable crypto assets on blockchain. Distributed ledger is one of the important implementation of blockchain. It is also considered as one of the powerful elements which makes blockchain popular. You can define distributed ledger as a database which is shared and synchronized across network, which is spread across multiple sites or geographies. Benefit of distributed ledger is it allows transactions to have public witnesses and thereby makes cyber attack very difficult. Distributed ledger uses computers to record and synchronize transactions. Apart from that, blockchain organizes information into small blocks that square measures in chain. Distributed ledger helps in information control mechanism by applying concept of uniqueness. There are four important artifacts which are required in order to implement distributed ledger. First component is distributed virtual machine. Then you have independent permission blockchain. Third is the network which takes responsibility of settlement. And you have smart contract which governs off-chain assets and also agreements. Objective of this video is to identify data storage structure of blockchain and essential elements of blockchain file. Primary objective of blockchain is to ensure that we are able to manage transactions better and faster than the conventional approach. Some of the biggest pain points that blockchain technology has to deal is related to scalability, latency issues, and also low throughput. In order to ensure that we are able to meet these three important limitations, we can depend on decentralized storage. Decentralized storage works by distributing the data across network of nodes. In other words, it will split the data and it will make the data available across network of nodes. In order to meet the practical demand of storing high volume of data, there are two different technologies which helps in decentralizing storage. One is swarming and second is sharding. Now let's go and understand what a shard is. In order to ensure that we are able to tackle with the current persisting issues with the validation mechanism, there is a new kind of protocol which has been adopted, and that is called as sharding. As part of sharding, only a small subset of nodes, which are also termed as shards, out of the entire network will carry out validation of every single transaction. So you can see here that you have Ethereum blockchain, which has divided your entire network into n number of shards, where shard A, shard B, shard C are three important shards. And they take responsibility of carrying out all the transaction validation. For example, shard A takes responsibility of validating transactions from 1 to 10. Shard B validates transactions from 11 to 20. And shard C takes responsibility of validating transactions from 21 to 30. This way, a lot of transactions will get validated because they are distributed across network. This can also provide capability of parallel processing. And if we are using parallel processing by distributing data across different shards, it will improve performance as well of the system. Apart from this, sharding also allows flexibility to the network. For example, as forced storage of all transactions on every single network actually becomes unnecessary if you are implementing shards. Blockchain implements shard, and we can configure our Ethereum blockchain in order to create various shards and distribute transaction validation capabilities on them, which can be parallelly processed. In order to build shards, one of the important entry is distribution key. This distribution key plays an important role in order to distribute transactions across different shards. By using distribution key, we'll be able to identify what transactions will be managed by which shard. Now coming to second technique, which is swarm. Swarm is set out to provide basic infrastructure for a new decentralized internet, which is used by blockchain. Swarm is a peer-to-peer file sharing protocol. This peer-to-peer file sharing protocol is used in order to network nodes, and it provides distributed digital service by contributing resources to each other. Typically, swarms let you store application code and data of the main blockchain in swarm node. It is connected to blockchain and it exchanges data on the blockchain. As we can see, swarm node contains client's file, and whenever required, these files are transferred onto Ethereum blockchain for processing. Now, what should be the typical structure of blockchain file? When we talk about typical structure of blockchain file, we have transactional data. Then we have block header that contains various important attributes that helps blockchain to identify objective and the purpose of that particular transaction. Then we have size and we have magic byte. Magic byte is used in order to identify the properties of your block header and transaction data. Typical distribution of blockchain file storage is by allocating specified number of bytes to each entry. For example, magic byte will have 4 bytes. Then you have block size 4 bytes. Then you have raw header, which contains raw header entry, which can be 80 bytes. Then you have number of transactions, which is an integer value. You have raw transactions. Depending on number of transactions, it can start with tx1, tx2, until and unless all transactions are not recorded. Then for another block, again, you can have magic byte, size of that particular block, raw header, and number of transactions which are present in that particular block. By using a typical descriptor your blockchain will be able to control and manage data which are stored in the blocks. Objective of this video is to list various prominent and popular blockchain platforms that are prominently being implemented today. There are multiple different popular blockchain implementations which are available today. Depending on the need and depending on the context, we can go and we can select the right implementation for our use. Ethereum, which is one of the popular implementations today. It is open blockchain platform that can be used by anyone to build and use decentralized applications which runs on blockchain technology. For example, Bitcoin. Bitcoin is not controlled by anyone, or it does not own Ethereum. It is an open source project which is built by multiple people around the world. Ethereum is adaptable and flexible, and apart from that, it is also open and public. So it can be used by anyone depending on if Ethereum meets the need of the business. There are some of the important tools that can be used. For example, we can use languages like Go, Python, C++ in order to develop applications for Ethereum. It also supports various different types of networks. For example, it can be public network, or it can also be smart contract based network where we have parties moving into agreement before they start conducting trade or business or transfers among themselves. Now, second important implementation is Hyperledger Fabric, which is B2B focused. It's a modular blockchain platform heavily contributed by IBM. It's again open source collaborative effort, which is used in order to create advanced cross-industry trade. It is a global collaboration which includes various different leaders from industry. There are many different projects which are under Hyperledger. We can go and we can use various capabilities of Hyperledger. For example, Hyperledger is popular because it is highly and actively updated in GitHub. In other words, it is distributed as a GitHub repository. We can use Hyperledger Fabric to create both public as well as private networks. Similar to Ethereum, Hyperledger Fabric also supports various languages. For example, we can use Python. Now, Corda, which is again an implementation of blockchain, has been developed to service specific needs of financial services. It was launched with a collection of world's biggest financial institutes, and it has created again open source distributed ledger, and this distributed ledger is what is called as Corda. There is no pre-built token or cryptocurrency for Corda, and it is permissioned blockchain. If it is permissioned blockchain, it means that it is not publicly accessible. It is restricted access to data, and agreement is what is explicitly mandatory. Ripple, again an implementation of blockchain platform, and objective was to ensure that we are able to connect banks, payment providers, various digital asset exchanges and corporates through a single network. Ripple fits for that. And it takes responsibility of also providing faster and scalable implementation as compared to others. This is the reason why Ripple is one of the solutions which is adopted for global payments. Quorum. It's enterprise-focused version of Ethereum, typically contributed by JP Morgan. JP Morgan has leveraged Ethereum, and they have created Quorum as one of the platforms which can be utilized in order to incorporate major Ethereum features. Again, similar to Ethereum, Quorum is also open source and it can be used by anyone. Now we need to understand that comparing platform is essential before we adopt it. In order to compare, we need to be aware about comparison parameters. For example, industry focus, governance capabilities, type of ledger, cryptocurrency support, consensus algorithm used, and smart contract functionality. These are some of the parameters which can be used in order to compare blockchain platforms. For example, if we compare Ethereum and Hyperledger Fabric, we'll find that industry focus is cross-industry. It is not specific to a particular industry. We can implement it across various verticals. Then we have governance. Governance in case of Ethereum is taken care by Ethereum developer, whereas Hyperledger Fabric governance is managed by Linux Foundation. Ethereum is permissionless, it means it's public. Hyperledger Fabric is permissioned, it means it's limited to a particular domain, or there is restriction in terms of availability. Cryptocurrency, Ethereum comes with Ether, that is ETH. Hyperledger Fabric does not have any cryptocurrency of its own. Algorithm used for consensus for Ethereum is proof of work, whereas in case of Hyperledger Fabric, we can use various frameworks for consensus algorithm. Smart contract functionality is provided by both of them. Depending on our need, we can go and we can compare various implementations using these important elements like industry focus, governance, ledger type, cryptocurrency, consensus algorithm, smart contract functionality to decide and then adopt the right blockchain platform. Now here you have a sample platform implementation. What we need to do in order to implement blockchain. First, we need to set up private blockchain, which can be done using various platforms. Then we have to set up devices. Once we have set up devices and private blockchain, we can integrate device data with blockchain. After integrating device data with blockchain, we can ask our developers to use APIs and develop client applications to meet the need of use cases. Objective of this video is to define various essential criteria that we must consider when selecting the right blockchain implementation. Before we select the right blockchain platform, we need to be aware about our domain and services that we are expecting from blockchain implementation. Then we have to start asking certain questions and making note of it. For example, you need to ask, do you need to store the state of the transactions? If yes, proceed further. If no, blockchain does not make any sense. Once you are assured that you need to store state, next question is, are there multiple writers? If no, don't use blockchain. If yes, move forward. Can you see an always online transaction protocol? If yes, don't use blockchain. If no, move forward and test again by asking, are all writers known? If all writers are not known, it means it is restricted blockchain implementation that you have to go for. If all writers are known, you have to further go and check, are all writers trusted? If all writers are trusted, again, you don't need to depend on blockchain for implementation. If all the writers are not trusted, then you have to move and do public verification requirement need. If public verification is done, if requirements are met, you have to go with public permission blockchain implementation. Else, you have to go with private permission blockchain implementation. So depending on these inputs that you will be collecting, you can decide on which blockchain implementation you have to go for. Now, there are certain typical use cases of blockchain implementation from perspective of usage. Blockchain implementation provides capability of proof of ownership, ensuring that all blocks and transactions recorded in block are immutable. Ownership cannot be changed. E-voting is another implementation domain where blockchain has played very important role in terms of ensuring that each vote is encrypted and is taken care in form of a transaction and make it tamper-proof. Smart contract is all about agreement. Blockchain takes responsibility of digitizing those agreements between parties, and that implementation is what is called as smart contracts. Trading and fair exchange protocol. This is one of the reasons why financial institutions and various industries are going and adopting blockchain. Decentralized autonomous organizations, where they can use blockchain in order to implement decentralization, and even stores can be decentralized if you are using blockchain. For interbank payments, where you have multiple different ledgers that you have to maintain. Blockchain adopts distributed ledger concept, so it becomes an essential component which can be used for interbank payments. Now, in order to adopt blockchain, we need to evaluate it from various functional dimensions. Security, be assured about it. Need of decentralization. What is the abstraction of privacy that you need? Expected scalability, which can be implemented by using sharding. Usability, providing extensibility to existing implementation. What is the cost benefit analysis, an outcome of cost benefit analysis? What would be operational impact on the system? And does that particular platform or application which you are going to adopt have sufficient community support or not? Once you are able to evaluate blockchain implementations, keeping all these important functional factors in mind, you will be able to adopt the right solution. Objective of this video is to illustrate management of cryptographic identity using blockchain. In order to demonstrate how to use cryptographic identity using blockchain, we have installed Hyperlaser Composer Playground, which is running at localhost 8080. Once we have logged in, we'll go and we'll find three important tabs. One is My Business, second is Network, and third is Connection. Connection type is web browser. My Business, we can go and we can import existing business network cards by clicking on Import Business Card. We can drag and drop a file which we have created with .card extension. Instead of following this approach, in order to explore identity, we'll create a business network card. To do that, we'll click on Create a Business Network Card. It will give us option saying Create a Business Network Card for blockchain if you have not connected to it before. We'll select Hyperledger. Once we'll select Hyperledger, it will activate Next button. We'll click on Next. Once we'll click on Next, it will ask basic configuration. You have to specify profile. For example, I'm writing here profile 1. It will ask you brief description about the profile. We'll write this as test profile. And then it will ask you organization. We'll keep the default. It will ask an MSP ID of the organization and the channel. We'll keep the channel also default, that is Composer channel. Then we can also go and specify commit timeout. We'll keep default. Now we have to go and we have to configure orderer. We'll keep the name as default, that is orderer.example.com. It will ask us URL of the orderer. We'll keep it default, that is gRPC localhost 750. It will ask us to customize gRPC max message length. We'll keep it default. We can also go and add other options if we want to. We'll not add other options because the objective is to explore identity. Then we have endorsing peer, which we have made selected. Then we have chain code query peer. We have selected that as well. These are the different roles which we want this org to follow. Then we have ledger query peer and we have event source. Apart from these configuration, we will also specify part of organization. Once we select part of organization, we'll keep it selected and we'll move to our final item, that is certification authority. We can specify name of the certification authority depending on we want to use certification of which signer or which signing authority. We can give name. For example, we can specify VeriSign. We can also specify URL which will be given to us by authority. As of now, I'm keeping it default, that is localhost 7054. And then you have to go and you have to enable verification process if you want the certificate authority to verify. We can check it. You can select. If you see it is disabled, but we can go and we can ensure that once certification authority is assigned and we have the right URL, we can go and we can select it. We'll click on next. Once we'll click on next, it will give us opportunity of configuring various options. to provide security credentials. For example, we can go and we can select certificate. We have to go and specify one of the two types, whether it is certificate or whether it is ID and secret. Depending on the availability, we can go and we can select certificate, or we can create ID and secret. We can go and we can drop the certificate here once we have created. After dropping the certification, we are set to use the certificate. If we are selecting ID, we can go and we can specify enrollment ID. This enrollment ID and secret must be created by someone who already have the business network you are connecting to. So you have to ensure that you have enrollment ID and enrollment secret. Then you can go and select card type, whether it will be participant or it will be admin. Admin will have capability of installing and starting business network. Participant card will have capability of connecting to a business network. So depending on the need, you can select the card type. Then you can go and specify name of the business network and name of the card. Once you have configured this, you will have your cryptographic identity set up in this particular blockchain implementation. Objective of this video is to install Hyperledger Fabric on Ubuntu 16.04. In order to install it, first we need to ensure that all prerequisites are installed. And first prerequisite is Go language. To install Go language, we'll go and we'll get Go language by writing wget followed by https storage.googleapis.com and we'll specify Golang. Followed by the tar file that we need, we'll specify Golang, and the version that we need is 1.7.1 and we want it Linux version, so we'll specify here Linux. Then we have to specify AMD 64 followed by TR, that is tar, and GZ, and we'll press enter. Once it is downloaded, we have to go and we have to untar it. In order to untar, we'll be using tar command, tar xvzf followed by go. So we'll write tar xvzf go 1 star.tar.gz and we'll press enter. And you'll find that it extracts all the packages which are there in this language. Once we have extracted all, we need to go and we need to install other dependencies. But before installing other dependencies, we'll be creating the directory structure. So we'll clear the screen first and then we'll create the directory structure. We'll write mkdir and we'll export go path equal to home/go path. And we'll also set an export to go root. Last variable that we will set here is to ensure that path of bin is specified for go. So we'll specify export path, retain the previous path, and then specify go root/bin. After setting the path, we have to set other few dependencies. For example, one of the dependencies that we are going to install here is sudo apt install lib ltdl-dev and we'll press enter. We'll say y and press enter. Our next objective is to go and install Docker. In order to install Docker, we'll get the Docker installer first by writing wget https docker.com/linux/ubuntu/disks/ubuntu type, which is xnl/pool stable AMD 64/docker CE, that is community version, 18.03.1 CE 0 Ubuntu AMD 64.deb, and we'll press enter. In case if you get an error using this particular URL, because there are sometimes changes which comes at the URL, you can try with other command. We'll use curl -fssl followed by the URL https download.docker.com/linux/ubuntu/gpg, and you have to add the key to it. So we'll just go and write sudo apt key followed by add and a hyphen, and you'll find a message saying OK. Once you find this message OK, it means that you have downloaded the repository which contains Docker. We need to go and we need to update it. So to update, we'll be using sudo apt-get update, and we'll press enter. So now it is updated and it contains your Docker repository as well. Now we can go and we can kickstart installation of Docker. To do that, we'll be writing sudo apt-get install -y, and we'll specify Docker CE. We'll press enter. In case if you are getting this package not available, you can try out with sudo apt-get install Docker, and you'll press enter. You can specify Docker and press enter, and you'll find that Docker is not currently installed. So we can install it by writing sudo apt-get install docker.io, and we'll press enter. We have to enter the correct command, and now it will take up this docker.io. Press enter. It will start installation of Docker. There are different ways in which your different Linux kernels are designed. Depending on the right way, you can go and you can install it. Once your Docker is installed, you can go and you can try starting the Docker service. To start Docker service, we'll be using sudo service docker start. If there are no errors, it means that Docker service has started successfully. We can also enable Docker to start whenever your system starts up. So for example, in order to enable, we can use sudo systemctl enable Docker. It is synchronizing the state, and now we can go and we can check the status of Docker as well by writing sudo systemctl status docker, and you'll find that it shows it's active and it is running. So now we have installed Go, we have installed Docker, and just in order to do final test of Docker, we can write docker images and press enter. You can specify sudo in case if there is a permission issue, and you'll find that as of now there are no images which are part of your Docker. So we have successfully installed Docker, we have successfully installed Go. Our next objective is to go and install Docker Compose. In order to install Docker Compose, we can use sudo pip install Docker Compose and press enter. If pip command is not found, we can try installing pip as well. We'll write sudo apt-get install pip, press enter. It's unable to locate pip, so we can try directly installing Docker Compose using install Docker Compose. We'll say Y and then press enter. So now we have Docker Compose also installed. It's getting installed. Now we have Docker Compose and Docker both installed. Now, in order to work with Docker images, we need to ensure that we have added our user to the Docker group, which was created during installation of Docker as part of setup. In order to do that, you can write who am I to know the user which you would like to add. Now we'll go and we'll add sudo user mod followed by ag Docker. This is the group which got created while installation of Docker, and will specify the username as view admin and will press enter. So now view admin is member of Docker group. So we have installed certain prerequisites. Now we have to go ahead and we have to try installing our Fabric. So in order to install Fabric, first we need to get the Fabric project, which is hosted at a GitHub. In order to do that, first we'll clear the screen and we'll use git command in order to create a clone of Hyperledger Fabric in our system. We'll write git clone and we'll specify https github.com/hyperledger/fabric.git and we'll press enter. Once it is cloned, you can go and you can try finding out by writing ls. Once you'll write ls, you'll find that you have a folder called as Fabric. We'll go into that particular folder. In order to move into that folder, we'll write cd Fabric and we'll do ls to explore. So we'll find all different components which are required are part of now Fabric folder. We can also go and we can locate certain core elements which are present in core and also certain examples which are present in example. We can go to cd examples and we'll do ls. Once we'll do ls, we'll find chain code, we'll find cluster, we'll find config tx update, we'll find e2e CLI, we'll find events and we'll find plugins. We can move to E2E CLI and we'll do ls here and we'll find certain YAML files which contains configurations. For example, you have config tx.yaml. This particular YAML file is used by config tx gen. It is used in order to build Genesis block for the channel and it contains metadata associated with the channel, which is broadcasted to order. Then we have crypto-config YAML, which is used to generate the certificates according to the organizational structure of the organizations which are participating in the blockchain. So we have successfully installed Fabric on Ubuntu. Objective of this video is to set up development environment for Hyperledger Fabric. In order to provide flexibility and to enable a number of dev, test and deployment scenarios, we have a tool called as Composer. Composer delivers various different components which can be installed using npm and it can be controlled from CLI. In order to install it, first we need to ensure that we have Node.js and npm installed, apart from other prerequisites which includes Docker. So in order to test whether those tools are installed or not, we'll go and we'll write sudo docker images and we'll press enter. We'll find that it gives us repository tag image ID created size. It means Docker is already installed. Similarly, we can write node -v to see whether node is installed or not. It gives the version of the node which is installed, and npm -v to give us what version of npm is currently installed. Once we are sure about these prerequisites installed, we'll be installing various CLI tools that are used in order to work with Hyperledger Fabric. In order to install essential CLI tools, we can go and we can use npm followed by install. We'll specify -g to make it globally available, and we'll specify composer CLI followed by the version that we want. For example, we want 0.19. We'll press enter. Once we'll press enter, it will connect to the repository and it will start downloading it and installing it. So now if you see, it has installed Compose CLI with some warnings. Now our next objective is to go and install utility that helps REST server on the machine to expose business networks using RESTful APIs. In order to do that, we'll be using sudo followed by npm install -g composer REST server @0.19. Ensure that versions are similar. Whatever version you have installed for Composer CLI, we'll try to keep similar versions. We'll press enter. It will fetch again from the repository and it will try to install. In the meantime, we'll try to download Visual Studio Code, which can be used as an editor. To do that, we'll click on Firefox, we'll minimize the terminal, and we'll wait for Firefox to launch. Once Firefox will launch, you have to go and you have to specify the URL that helps you to download Visual Studio Code. So we'll write https followed by code.visualstudio.com and downloads. Press enter. It will give us download option where it will ask us to select the version and also the installation type. We'll select deb. We'll click on save file, click on OK, and we'll wait for this download to finish. In the meantime, we'll go and see the status on our terminal. Now, once we have Composer REST server installed, our next objective is to ensure that we are installing a utility that will be used for generating application assets. And to do that, we'll be first clearing the screen. After clearing screen, we'll be using sudo npm install -g generator Hyperlaser composer @0.19, and we'll press enter. This will help us to generate various assets which are required. As we wait for the installation, we will install Visual Studio. Open the download folder, right-click at the dev file and open the installer. The installation will start. It will ask for the admin password to proceed further with the installation. Enter the password and click OK. We will wait for the installation to complete. So once we have these packages installed, we can close and we can go for final setup, and that is to install Yeoman. Yeoman provides you capability of generating applications which will utilize Hyperledger Composer capabilities. In order to install Yeoman, we'll be using sudo followed by npm install -g and yo, that is yo. It will ask the password. You can enter the password of your Linux box and it will start fetching it from the repository and it will install it. We'll wait for the installation to get over. In order to confirm that our Visual Studio is installed, we can go to Application and Programming, and we can click on Visual Studio Code to launch it. And here you have your Visual Studio Code, which is launched. So you have now ID, which is installed. We'll go back to our terminal to see progress of Yeoman installation. So now we need Visual Studio Code and we need all the installations to be completed at the terminal. We'll wait for Yeoman installation to get over. So once you get these messages where it does the check of Yeoman and you get the complete details about all the packages which are installed here, it means Yeoman is installed. You can go and you can clear screen now. After installation of Yeoman, you are ready to go and utilize Hyperledger capabilities. We'll minimize the console for now. And now we have to ensure that we have the required extension added to our Visual Studio Code. In order to add extension, we will go to Extensions, click on it, and we'll write here extension that we want. We want to have extension that helps us to write Hyperledger Composer. So we can just go and install the first one, which is Hyperledger Composer syntax highlighting. We'll click on install. You'll find a message saying installing. Hyperledger Composer extension for Visual Studio Code takes responsibility of defining the structure and also validating the structure from perspective of asset, participants, and transaction. Now you have your Hyperledger Composer installed. We can click on close. And we can go to File. You can browse various options that are used in order to help you in writing programs. Finally, we'll close Visual Studio Code. We'll go to Terminal. And we'll write here Yo Doctor. We'll be frequently using this Yo Doctor in order to ensure that we are able to see whether tools are behaving properly or not. We'll say Y and we'll press enter. Yeoman Doctor runs and it does the entire check for your Yeoman installation. So now we have installed all the required tools which will be used by developers in order to write applications. Objective of this video is to recall common usage of various essential Hyperledger Fabric commands. You need to ensure that you have installed the Hyperledger and you have started the Hyperledger Fabric. In order to ensure that you have started it correctly, we can go and we can move to that particular directory. We can specify cd, fabric, dev, and servers. We'll press enter. After we press enter, we'll go and first we'll try to stop the fabric. In order to stop the fabric server, what we need to do is we need to use sudo followed by // followed by stop fabric .sh and we'll press enter. It will ask for the password. You can specify your Linux password and press enter. It will take some time to stop. We'll wait for it to stop. So it stops the peer, it stops the CouchDB, which is the database, it stops CA, stops orderer, and once everything is stopped, you have a clean install or dev environment ready. Now we'll go and we'll see how actually we can start Fabric and we can create peer admin card. Before we restart our Fabric, we need to ensure that we will download the previous admin cards which are created. To do that, we'll write sudo followed by // teardown fabric.sh and we'll press enter. Now it has quickly executed the command and everything is now set to pre-start mode. We'll clear the screen for now. After clearing the screen, we will start Fabric server again. To do that, we'll use sudo // we can specify a Fabric version of our choice. So we can do that by using export Fabric version. We can go and we can check if Fabric version is already set. In order to do that, we'll write echo followed by Fabric version. We'll press enter. If you see it is not set, we can go and we can now export. We can use export. We can specify Fabric version And we can give it a version. For example, we'll give HLFV11 and we'll press enter. After setting it, our next task is to go and start our fabric. To do that, we'll use sudo /start and we'll specify fabric.sh. When you start this server for first time, it may take some time because it will download various images in order to ensure that it has all the elements to run a fabric ledger. We'll press enter. So it creates a network that is Composer default with the default driver. Then it creates CA, it creates orderer, it creates CouchDB, and it creates peer. Now you'll find that last message which it displays is 066 successfully submitted proposal to join the channel. Now we can go and we can create a card. To create a card, we'll write sudo /create peer admin card.sh and we'll press enter. Once we'll press enter, it will use CLI and you'll find that command succeeded and it has created a .card file in TMP directory. It deleted business network card, which was previous one, and it successfully imported business card in the corresponding file. Objective of this video is to demonstrate the steps and the approach of application development using Node SDK on Hyperledger Fabric. In order to do that, first we need to ensure that all prerequisites are installed. Prerequisites which are required are some of the libraries of Hyperledger Composer. We'll assume that they are installed and we will launch application. Clicking on application, it will give us an option called programming. From programming menu item, we'll click on Visual Studio Code. Once we have clicked on Visual Studio Code, we'll find welcome, we'll close welcome, and we'll keep terminal on. In case if terminal is not visible, we can go to view and we can select integrated terminal. Now once terminal is present, we can go and we can do installation of some of the essential packages which are required in order to build an application for Hyperledger Composer. To do that, first dependency that we need to install is Yo. We'll assume that Yo is installed. In case if you want to check, you can go and you can write Yo doctor. Once you will write Yo doctor, it will tell you what is the current health and status of Yeoman which is installed. So we have now the right version of npm node. You can close in case if you are getting some messages. You have node path which matches npm root. Node.js is also installed, but you don't have bower rc and yorc.json. We'll clear screen as of now and we'll go and install some of the dependencies. First dependency that we need to install is typing. In order to do that, we'll go and we'll write sudo install -g typings and we'll press enter. We'll specify the password. Once you find some errors, you might have missed some element or some typo. Ensure that you are not missing any command. We'll press enter by writing sudo npm install -g typings. It will connect to repository and it will try to fetch typings and it will install it. We'll wait for installation to get over. Once typing is installed, your next objective will be to install bower, which will take responsibility of transcribing your code as per the browser. We'll go and we'll install it. We'll write npm followed by install -g bower. Never forget to specify super user. So you have to go and you have to add sudo before beginning of the command and press enter. Once bower is installed, our next objective will be to provide Angular CLI so that applications can have visual unit created using Angular. To do that, we'll use sudo. We'll write sudo followed by install followed by -g and we'll specify Angular Cli. We'll press enter. In case if there is again error, we can go and we can always correct it. After sudo, you need to ensure that you are using npm. Now we have installed Angular Cli. Our next component that you have to install is generator, which takes responsibility of helping you to quickly build applications which are based on Hyperledger Composer. To do that, we'll again write npm followed by install. Ensure that you are specifying sudo followed by -g and specify generator Hyperledger Compose and press enter. So you are writing sudo npm install -g generator Hyperledger -composer. Press enter. It will fetch from the repository and it will install this generator globally so that whenever you want to create skeleton application, you can create it by using Yeoman. We'll wait for this install to get completed. Now once you get generator Hyperledger Composer at the rate 0.19.13 installed, you are set to go and build applications using Hyperledger Composer. For example, in order to build one, we'll first create a directory. To create a directory, we'll write mkdir first app. Now we have created a directory. Name of the directory is first app. We'll change the directory. Once we are there in first app, we can go and now we can create an application executing yo command, which is of Yeoman, and specifying the name of the generator. We need not specify generator to start with. We can directly specify Hyperledger-composer. So we'll go and we'll specify that. We'll write yo followed by Hyperledger Composer and we'll press enter. Once we'll press enter, Yeoman will start creating the application. Now we have to select option what type of Hyperledger project we want to generate. We can create Angular project or we want to connect to a running business network. We'll say end to it and we'll press enter. Now it will start asking questions. What should be the name of the app? We'll keep default. Description. If you want to give a description to this project, you can specify, else press enter. If you want to specify author name, you can specify email ID followed by license. We'll keep Apache. And then it will ask you business network archive file. Path for the current working directory, we'll press enter. Then you can also specify REST server address. For example, we'll say test. We'll press enter. It will ask port. Let's keep the port as 3000. And then it will ask namespace. We can select whether we want to use namespace or we don't want to use namespace. We can say namespaces are not used. And then finally, it will give us an error saying that we don't have the digital component, which is part of Angular. We don't need to worry as of now because we can go and we can customize this when we write a full-fledged application. We can go and we can do ls. We can go and we can edit the file and we can follow the same process of creating an application, which is meant for Composer. We can try creating once again by writing yo Hyperledger Composer, press enter. And now it will ask us what kind of application or project you want to create. Angular, project, a business network, loopback, model. We'll select Angular. Do you want to connect to a running business network? We'll say N. We'll give project name, Hyperledger Composer project, author name, email, license will keep as it is. And now it is asking business network archive file, path of the current working directory. So we can specify path of the current working directory, which can be, if you will not specify, it will locate digital property network BNA. So whatever we have created, we can specify name of that particular folder. We can press enter. We can keep the REST server by default and REST server port. Also default, that is 3000. And finally, we'll get that index.js file is having some issue in this particular case. So we have specified the steps that we have to follow in order to write a Hypercompose application. Now it's time to test your knowledge and understanding of what we have learned in this course. In this exercise, you will stop Hyperledger, you will start Hyperledger, and you will start Composer Playground. Now I want you to pause this video and attempt all of the exercises and then come back to view the solutions so you understand how well you have attempted. In order to stop your Ledger Fabric, you need to ensure that you are there in Fabric Dev Server. You have to write ls. Once you will write ls, you will get the scripts, that is start Fabric, stop Fabric, tear down Fabric. In order to create a new fabric and start it once again, we need to first go and stop it. In order to stop it, we need to go and we need to ensure that we are using sudo /stop fabric.sh command, and we are pressing enter. Once we'll press enter, it will ask for admin password. We can specify the password of the Linux box and we can press enter. Once we'll press enter, it will run the script named stopfabric.sh. It will unset assuming HLFB11. It will stop peer, it will stop orderer, it will stop CouchDB, and it will also stop CA. Once it is stopped, we can go and we can start it again. In order to start, you'll be using sudo /start fabric.sh and you'll press enter. Once you'll press enter, it will start running the fabric where it will remove the existing peer and it will create the new peer with the similar name. We'll wait for fabric to complete startup. Now, once you see this message, info006 successfully submitted proposal to join the channel, it means that your fabric has started. Now, let's go and start the web app, that is Playground. In order to start Composer Playground, we can go and we can write Composer followed by Playground and press enter. Once you will press enter, it will try to bind HTTP localhost with a port 8080. And it will start Playground API on 8080 and it will launch it in a browser. We can go and we can specify localhost and it will load Hyperledger Composer in order to prepare blockchain. Once it has loaded, it will start initializing the Playground. You will get certain errors. You can ignore those errors. Once your Composer Playground is up, you can go and you can create business cards in your wallet, or you can see what all business cards are there in your wallet. You can go and you can import existing business network cards in your wallet. Objective of this video is to illustrate the essential ecosystem of Bitcoin blockchain. Bitcoin is one of the innovations that has brought in concept of digital asset. Cryptocurrency is a digital asset which is designed in order to work as a medium of exchange. It internally uses secure cryptography in order to ensure that all financial transactions are secured. It controls the creation of additional units and also does verification of transfer of assets. Bitcoin adopts peer-to-peer technology, which is one of the essential implementation of blockchain. One of the additional features that makes Bitcoin popular is there is no central authority. Your assets are digitized and they are managed in a digital way. There are some of the essential features which makes Bitcoin different as compared to existing currency. First is validity. Its validity is increasing, and various businesses are adopting Bitcoin as a medium of exchange. Decentralization has brought in huge power for Bitcoin. For example, you have distributed ledger, which can be typically described as a ledger of any transaction or contract maintained in decentralized form across different locations. It also eliminates the need of central authority to check against manipulation because everything is digitized. There are various decentralized components which makes essential part of Bitcoin. For example, you have decentralized money, you have decentralized mining, you have decentralized ledger, and you have decentralized transactions. So all of them are made available in isolation, and that makes it secure and one of the prominent technology which can be used in order to have transfers digitized. Now, what all are the essential components that makes up Bitcoin? First is you need to have blockchain layer which maintains blocks. On top of that, you need to ensure that Bitcoin protocol is adopted. It can be done by taking up Bitcoin core. You can divide the entire architectural component into two categories. One is currency component and second is client component. For Bitcoin currency, you have Bitcoin protocol and client where you can send, receive, and also maintain transactional audit of all the transactions that are going on. Apart from that, it also supports alternate currency, and for that, you have different currency protocol and client. So by putting together blockchain platform, Bitcoin protocol implementation, client layer application, and Bitcoin currency identifiers and APIs makes entire Bitcoin architecture robust and also a good medium of trade. There are various different types of Bitcoin transactions. To classify, we can pay to public key. You can pay to a particular Bitcoin address which can be generated by using Bitcoin address generators. Then we can also pay to script hash, which is based on hashing algorithm. We can have multi-signature transaction where a single transaction is signed multiple times by multiple layers in order to ensure that transaction is more secure. Then you have op return metacoin, which is one of the approach which we can adopt in order to have Bitcoin transaction. Then there is a non-standard approach of Bitcoin transaction as well, which provides a unique approach of Bitcoin transfer and also manages transactional mechanism using non-standard approach. In order to understand Bitcoin block, which is again an implementation of blockchain block, we need to understand that it contains various different fields. For example, you have fields like version, which specifies what is the current Bitcoin version. Size of that version field is 4 bytes. Then we have previous block hash in order to maintain the chain. It is 32-bit. Then we have Merkle root, which is again 32-bit. We have timestamp, which tells what is the time of the block creation. Difficulty target is the difficulty target of the block which is being created. And also N1s, which is a counter which is used by miners to generate correct hash. Apart from that, we can also link the block back to the previous block by using previous block hash. Objective of this video is to identify essential factors leading to the significant rise of the Bitcoin currency. There are growing number of services and merchants who are accepting Bitcoin all over the world today. We can use Bitcoin to pay them and rate experience to help them gain more visibility. Some of the important factors which is contributing to rise of Bitcoin is its support to cryptocurrency, which is digitized currency and provides better security mechanism. There are many countries in the world which has adopted Bitcoin even in government sector. So there is huge government support which is rising in order to ensure that cryptocurrency is adopted. Apart from this, you'll find investors investing huge in Bitcoin because of some long-term benefits which they have realized with their past investment, and also with the growing investment in Bitcoin, we can have a sense that acceptance of Bitcoin is increasing day on day. Companies have been doing huge investment in Bitcoin, and every company is doing some or other blockchain implementation and have adopted blockchain as one of the major contributors in financial and other domains. Even market capitalization of Bitcoin also proves that how well it is rising, and with lots of companies coming together and communities improvising Bitcoin, it is bound to develop in future. Some of the benefits which can be realized of Bitcoin in trade are user anonymity, where by making user anonymous, security needs can be met, and it becomes a very important security mechanism to keep user anonymous while trade. Bitcoin is not owned by anyone, so there will be no third-party interruptions. Neither you will need some third-party verifier to verify your transactions. All that will be taken care by internal Bitcoin architecture that makes it more popular and efficient in order to be adopted in trade. Apart from this, direct benefit to the consumers because they do tax-free purchases. All purchases using Bitcoin are tax-free. Apart from this, instead of paying huge transactional fees for other trade mechanisms, Bitcoin is quite low as compared to them, which itself is making huge leap in terms of adopting Bitcoin. Bitcoin is mobile compatible, so we can go and we can have mobile applications also trading using Bitcoin. Now let's evaluate some of the direct benefit that we get because of cryptography adoption in Bitcoin. First one is consensus. It is eventual. Then exponential convergence, that is adopting new technologies and also breeding technologies by using Bitcoin inside their architectures. Liveness, correctness, and fairness. These three are prominent reasons why cryptography has been adopted, and around cryptography there are many frameworks which are coming up. With this particular graph, we can clearly see how Bitcoin is doing as compared to other blockchain platforms. There is a huge rise, and as contributors and other blockchain implementations are gaining momentum, there is a revenue share which is happening among different implementations. Objective of this video is to describe the underlying objective of full node, validation, and block. Now, whenever we talk about distributed network model, node is one of the essential components of it, which provides capability of intersection or connection within the network. Node works as a redistribution point or also sometimes communication endpoint. In other words, Bitcoin node functions within the Bitcoin network, providing capability of enabling redistribution point or communication endpoint. As already indicated, Bitcoin node functions within the Bitcoin network with the objective of providing capability of validating the transactions which are happening. These transactions are typically blockchain transactions. There are different types of nodes which are supported by Bitcoin. You have full node, you have super node, and you have minor node. Full node is an integral component of Bitcoin network because it takes responsibility of validating the blockchain. And it does that by downloading a copy of blockchain on it. Full node is also capable of relaying transactions and recent blocks, but this isn't required to be considered a full node. Now, when you open up a full node client like Bitcoin Core, many people sitting behind a firewall may have limited number of connections or may limit number of connections. Your full node is limited in number of connections. As per standard, it can connect to around 8 and only look for super node, which is listening node. Now, in distributed network, when we talk about super node, it functions as a highly connected redistribution point and also behaves as a relay station. Therefore, this would be an appropriate term to describe a publicly connectable full Bitcoin node. This means that multiple nodes can connect to it and they can obtain all the transactional data and blockchain history. One downside is super node may need more bandwidth and CPU as compared to full node because it does certain extra tasks as well. Then we have minor node. Minor node is utilized for mining programs, which takes responsibility of separating from Bitcoin core in order to mine Bitcoin blocks. Now let's understand full node. Full node is an integral component of Bitcoin which takes responsibility of validating the blockchain and also provides relaying transactions and recent blocks. But yes, it has limited number of connections and it can connect through supernode. In order to connect to external publicly available nodes, it has to use supernode. For example, if you see, all full nodes are not publicly connected. But when we talk about supernode is treated as a redistribution point, which is well connected, works as a relay station, and it provides publicly connectable full Bitcoin node. Node can connect to obtain not only relayed transactional data, but also is capable of gathering blockchain history. Finally, when it comes to miner node, it is used to mine Bitcoin blocks, and it is typically a full copy of your blockchain data. There are different ways in which miner node can work. It can be solo or it can be pool miner. There are two types of miner node as described. One is solo miners and second one is pool miners. Both of them adopt full node principles. Now let's understand how actually payment processing is done using Bitcoin transaction process. We can take example of different type of transaction modes. For example, you have two computers, computer A and computer B. If you are using hash script in order to transfer, your computer B will have copy of script hash, whereas computer A will have private key, which will be applied on full public key in order to redeem the script. And finally, it will use script hash in order to communicate with computer B for handshake. Once handshake is done, you will have transaction invoked. This is done in order to create a P2SH, redeem script hash to receive payment. Similarly, when we go with payment processing with Bitcoin from receiver's perspective, not from payer's perspective, you'll be ordering a price. Using that, a request payment will be invoked. That particular payment will be verified and order fulfillment will be done. Apart from that, there are certain optional tasks that can be part of your payment processing. For example, you can have optional refund, you can have optional income dispersal, or you can have optional recurring billing. So these are two different ways in which payment processing can be done using Bitcoin transaction process. And now we'll have Bitcoin block structure. Bitcoin block is a collection where actually you will have different ingredients placed together to create a block. Some of the important participants are transaction, then you'll have public key, you'll have signature for handshake, then you'll have hash, which will be used as an algorithm in order to derive the signature using public key, and you will have private key. So in case if there is transaction which is happening in network where you have multiple participants like A, B, C, D, there will be handshake and a chain will be created of a transaction where verification will be done by the appropriate participant. For example, B's public key will be verified using B's signature. Similarly, A's public key will be verified using hash algorithm and deriving the A signature. When we talk about C and D handshake, C's public key will be verified using hash and the signature. Finally, all the participants will have their private key, which will be used in order to sign in. So by adopting Bitcoin block structure, we can ensure that cryptography works better and we are able to derive currency value out of cryptography technology. Objective of this video is to install Bitcoin Core. In order to install Bitcoin Core, we need to ensure that we have Linux box. In our case, it is Ubuntu, and we are using 16.04. To start up with the installation, we need to first launch the terminal. In order to launch terminal, we can go to application, we can go to system tools, and we have terminal here. Once we will launch terminal, we need to go and ensure that we have added the repository which contains Bitcoin Core installer. To add a new repository to your Ubuntu, you have to use a command called sudo followed by apt add repository, and we have to specify PPA, which will be used in order to identify the repository, then Bitcoin/Bitcoin, and we'll press enter. Once we'll press enter, it will ask password, that is super user password. We have to specify the password of our Linux, and we have to press enter. Once we'll press enter, it will add Bitcoin repository to our existing repository. We can press enter to continue. We have to wait for some time. It will create keyring and it will try to add your PPA for Bitcoin. Once it is imported, you'll find the total number processed will show 1 and imported. And most important message that you need to look for is OK. Once you see OK, it means that you have added the repository which is required in order to install Bitcoin Core. We'll clear the screen and we'll move on to next step. In order to ensure that whatever is added in the repository can be brought in the local repository so that we can install Bitcoin, we have to go and we have to execute sudo apt-get update. To do that, we'll write sudo apt-get update and we'll press enter. Once we'll press enter, it will connect to repository and it will try to download whatever dependencies are there along with updating the existing repository with Bitcoin. We'll wait for this update to get over. Now we have to visualize last 3 messages where it tells that it is fetching it from Bitcoin. Final message that you need to look for is reading package list done. We'll clear screen once again. After clearing screen, we are now ready to install Bitcoin Core. Now we are ready to install Bitcoin Core. After we clear screen, we are going to install Bitcoin Core. In order to install Bitcoin Core, we have to execute a command. That command is sudo apt-get install, and we have to specify Bitcoin Qt. We'll press enter. Once we'll press enter, it will read all the dependencies and it will finally ask you, do you want to continue? You have to press Y and press enter. Now it connects again to Ubuntu repository and it starts downloading and installing the dependencies. Once it is installed and once you get the console back again, you can go and you can verify whether it is installed or not. To do that, you'll go to applications. You can go and you can search for application. We'll minimize it. And you'll find an internet Bitcoin Core. Once you find Bitcoin Core, it indicates that your Bitcoin Core is installed. We'll click on it. Once we'll click on it, we'll get a welcome message saying welcome to Bitcoin Core. And you can go and you can select whether you want default data directory or you want a custom directory where you want to store copy of Bitcoin blockchain. It clearly indicates that you need 203 GB, out of which, since we are using a virtual machine, 7 GB is available. We can click on OK. And we'll find that Bitcoin Core starts and it loads the wallet. Once it loads the wallet, it provides you facility of sending and receiving Bitcoins and also helps you to browse transaction history. Once you get this dashboard, you can be assured that your Bitcoin core is installed. Objective of this video is to identify essential elements of Bitcoin network configuration. In order to work with Bitcoin network, first task is to do node installation. In order to do node installation, you need to ensure that you have checked up with all the prerequisites, you have verified release signature, then you have downloaded it, and you have also done installation depending on your operating system. Post installation, you have to go and you have to do configuration. And as part of network configuration, you need to check inbound connection through Bitcoin core. You can also check inbound connections through BitNodes. These are different approach of checking inbound connections. Then we need to go ahead and we need to enable network so that participants can participate and they can utilize Bitcoin capabilities. In order to hide and secure your Bitcoin core or installations, you can configure firewall as well. Now, what all are the essential components of Bitcoin network? First is full node client. Then you'll have network itself, which will contain distributed network component and also will have various configuration element in order to ensure that network is set up properly. Then mining is what is one of the essential features of network, which keeps track of what's going on inside. Then wallet is also an important component because all the transactions will be done through wallet, where sending or receiving, utilizing appropriate credentials, utilizing appropriate send and receive address is what need to be specified. Then we have miner. You have to configure your miner nodes, which can be pool or which can be solo. And then using appropriate protocols in terms of generating Bitcoin messages is what is essential part of network configuration. As a diagram which looks complicated, you'll find different clients. You'll have client, you'll have core client, then you'll have miners, which will be pool or solo. Then you'll have wallets, you will have router, which can be used in order to create communication between various full node clients. Then you will have thin client wallet. You can also use RESTful services in order to interact with wallet, which will be managed by Stratum servers. Then you can have pool servers, which keeps track of all the miners which are part of the particular pool. So by using essential components and configuring them in different configuration files, you will be able to manage Bitcoin network component. Now let's talk about most important file for Bitcoin configuration, and that file is bitcoin.conf. There are certain configurations that we have to do in bitcoin.conf. First one is testnet, which takes responsibility of enabling or disabling run on test network instead of real Bitcoin network, and that can be done by passing either value 1 or 0. 0 is for disable and 1 is for enable. If you select 1 or if you specify 1 here, it enables to run on test network rather than running on real Bitcoin network. But if you say 0, that is disable, it means that it will directly run on a real Bitcoin network. Then we have proxy, which is used in order to proxy the calls or proxy the communication to your Bitcoin network. You can connect via a SOC 4 proxy, which is a proxy configuration that can be done. And that is done by using proxy and passing the appropriate proxy port and IP to it. Then in case if we want to add more nodes, we can do that by using add node and specifying its IP and port. You have to set as required to connect to specific peer. Since Bitcoin is peer-to-peer, you have to go and you have to specify a specific peer to which you want this current node to connect. Then we'll have connect. You can use as many connect, as many add node as you want in bitcoin.conf. Connect requires specific peer information to which you want your current Bitcoin network to connect to. Then you have no IRC, which is used to specify whether you want to use internet relay chat or not. Internet relay chat is used in order to find other peers, and that is done by using Bitcoin channel. Depending on your need, you can specify whether you want internet relay chat to discover other peers or not. If you don't want, you can pass there 0. If you want, you can pass 1. So when my bitcoin.conf file contains no IRC equal to 1, it means that it will find other peers using internet relay chat. If it is 0, it will not. Objective of this video is to specify steps and approaches of managing and configuring Bitcoin configuration. One of the important tasks is to ensure that your Bitcoin is always tuned. In order to ensure that initially when synchronization will happen of Bitcoin, it may take time because it has to download lots of data. In order to ensure that that download is successful, you should make sure that you have enough bandwidth and storage for full blockchain size, and as expected it can be more than 150 GB. Now, one of the tuning configuration that is needed is to ensure that we are utilizing our storage in best possible way, and that can be done by tuning the storage. So tuning storage is one of the essential component that we have to apply when we are setting up our Bitcoin core. Then reduce traffic is again in order to ensure that we are able to optimize connectivity in order to dedicate more bandwidth to the transactions. We would like to reduce the traffic, and to do that again we can go and tune configuration. We need to always configure maximum upload target. Depending on the need and depending on the size as we expect in our Bitcoin core, it is essential to go and configure it so that it can utilize optimum amount as per our preferences. Disable listening sometimes may add value to your Bitcoin performance. Don't depend on default connection because the default connection may not be optimized as per your current system availability. So always reconfigure maximum connection depending on your system capability. Try to use block only mode in order to ensure that your Bitcoin transactions are robust. Now, how actually we can tune our Bitcoin? We can adopt a predefined mechanism or approach. For example, we can start Bitcoin core with options. We can edit configuration files in order to optimize the resource usage. We can also control Bitcoin core daemon. For example, in order to specify daemons of Bitcoin, you can specify Bitcoin D minus PAR equal to 2 and you can run it as a daemon process. Then Bitcoin core GUI can also be configured by using Bitcoin minus QT followed by minus PAR equal to 2. When we are setting up our Bitcoin core, there are certain important guidelines which we need to look into. For example, you have to always go and try regulating traffic consumption because Bitcoin has a predefined limit. Bitcoin allows only up to 125 connections to different peers, 8 outbound and a maximum of 117 inbound connection. So you have to utilize these connections effectively. Recommended size of max upload target is 144 blocks per day, which is maximum 144 MB per day. Also ensure that you have configured firewalls of your computer and open up only 8333 port for communication. Try adjusting maximum connected node to a minimum if the traffic limits are small instead of opening maximum connected nodes. So try to reduce it so that it is balanced. Objective of this video is to illustrate the essential features of Bitcoin wallet. Bitcoin provides free wallets, which are available for almost all operating systems and also other devices to serve a variety of needs. For example, we can install an app in mobile device for everyday use and we can use it for our online payments. Bitcoin wallet is becoming popular because of its privacy and security features. For example, when it comes to privacy, it is not mandatory requirement to submit any personal information. You need to have a Bitcoin address which can be generated using various Bitcoin address generators. It generates key as well as the address. Apart from that, it automatically generates a new public key for every transaction, ensuring that every transaction is secure and private. Automatic denial of payment to the same address twice. This ensures that one transaction, one payment. And privacy is easy to implement, and this makes Bitcoin wallet easy to use as well. From perspective of security, Bitcoin wallet uses best possible security mechanism, that is two-factor authentication, and also password protection. Apart from this, in order to secure your wallet, it has a predefined and pre-configured timed logout. Now, there are certain features of Bitcoin wallet. Apart from using wallet for sending and receiving payment, we can also import and export private keys. We can accept multiple cryptocurrencies, which makes Bitcoin wallet one of the flexible wallets which are available today for cryptocurrency management. We can also configure recurring billing and invoicing feature. It has a smart QR scanner which can scan the code and the address of a Bitcoin receiver or sender. We can buy, sell. It can also provide prominent advices based on average cost per coin. We can create payment requests in any world fiat currency. So it is currency independent. It makes Bitcoin wallet currency independent. So you don't need to worry about currency while trading using Bitcoin. In order to make Bitcoin more flexible and usable, you can set up spending limit. You can also go ahead and schedule payment, and you can apply multiple signature functionality for better confidence and usability of the wallet. Now let's see how Bitcoin wallet works. Customer will connect to Bitcoin terminal. Through that terminal, there will be a connectivity which will be invoked to Bitcoin server. Using Bitcoin exchange, it will send the message to server BTC wallet, which will be finally credited to customer's BTC wallet. So there are multiple participants who participate in a complete Bitcoin wallet workflow. Server being essential one, then you have exchange, which takes responsibility of message interpretation. Then we have wallet, which is the store of all the transaction and the information. And you have customer who owns Bitcoin credentials and also a particular address. Terminal takes responsibility of working as a proxy to the customer so that it can talk to the server. Objective of this video is to demonstrate how to set up the Bitcoin Core wallet, client, and invoke transactions. Once we have installed Bitcoin Core, we'll find it in applications. We'll go click on application. We'll go to internet, and in internet, you'll get Bitcoin Core. We'll click on Bitcoin Core and it will launch Bitcoin Core client. Once you will launch Bitcoin Core, you'll find the main window of Bitcoin Core. From here, we can check balance, we can send and receive Bitcoins, and also we can keep track of transactions. We'll go and we'll click on hide on the welcome message. That is, it is giving us an indication that recent transaction may not yet be visible, and therefore your wallet's balance might be incorrect. So we'll keep this message as it is and we'll click on hide. Once we'll click on hide, it will show the balance. What is balance, what is total, and what is pending. Now, first thing that we would like to do is to set a password for our wallet. Password will ensure that it encrypts the wallet and make it secure. In order to do that, we can go to settings. From settings, we can select an option called encrypt wallet. And we can specify a passphrase here, passphrase of your choice. Rule that applies on passphrase is 10 or more random characters or 8 or more word. So we can specify. We can repeat the passphrase. and we can click on OK. It displays a warning. If you encrypt your wallet and lose your passphrase, you will lose all of your Bitcoins. So ensure that you are remembering the passphrase that you have entered. We'll say yes, encrypt it. In case now Bitcoin will close now to finish the encryption process. Remember that when you encrypt your wallet, it cannot fully protect your Bitcoin from being stolen. So this is a warning in order to ensure that we don't claim in case if we share our passphrase with someone, and we can click on OK. Once we'll click on OK, it will shut down the Bitcoin core. Again, we'll go and we'll launch our Bitcoin core. We'll go to Application, Internet, and we'll click on Bitcoin core. It will load the block index. We'll say hide. And now in order to do transaction, that is send and receive, we can click on receive, where you can request payment by generating QR code and Bitcoin URI. Then you can send coins to a particular Bitcoin address. So if you have participants whose address is there with you, you can send the Bitcoin to them, as well as you can invoke a request for receiving the payment. And transactions will show you the list of transactions that you have done. Click on send to verify the options. We can go and we can specify a Bitcoin address wherever you want to send. So for this, you need to have address which you can maintain in an address book as well. We can add addresses of Bitcoin. Ensure that you are specifying a label. For example, I'll specify Daniel. We can specify here a Bitcoin address. This address is something which will be associated with list entry. It can only be modified. We'll click on cancel for now because we don't have any logical address. So once you have address of the payee, you can use this send button in order to send payment. Similarly, you can place a request, specify a label. You can specify amount. You can also go and select MBTC or UBTC, which is one of 1,000,000, which is micro Bitcoin. You can go and you can select MBTC as well, which is milli Bitcoins. And Bitcoin is a unit. You can generate SegWit, Bench32 address, and you can click on request payment. So we can go and specify a message, hi, and we can click on request payment. Once you click on request payment, it will give you QR code. You can copy the QR code, you can copy the URI, you can copy address, and finally you can send the request. You'll close it, and your message will be sent to the address that you have specified. Finally, you can keep a track of all the transactions by clicking on transaction. So by using Bitcoin Core Wallet, we can go and we can send, receive, and track transactions. Objective of this video is to illustrate how to facilitate communication with Bitcoin Core using Node.js package. So now we'll be building a Node.js application and we'll see all the dependencies which are required in order to collaborate logic so that we can communicate with Bitcoin Core. In order to do that, we'll go to Application, we'll come to Programming, and we'll click on Visual Studio Code. Once we'll have Visual Studio Code loaded, we'll go and we'll get the integrated terminal. To get integrated terminal, in case if it is not available, you can go to View and you can click on integrated terminal. You can use shortcuts as well. Now we'll be creating a directory. In order to create a directory, we'll write mkdir followed by node app and we'll press enter. Once we'll press enter, it will create a directory called node app. We can go and we can now move into that particular directory. To change the directory, we'll be writing cd followed by node app. We can write pwd to see the current path. Our directory is created under home, user is view admin, and name of the folder is node app. Now we'll start installing the dependencies. Before installing dependencies, we need to go and initialize this package. To do that, we'll be using npm followed by init -y. Once we'll write this command and press enter, it will create basic package.json file, and it will write that basic package.json file within your node app. We'll clear screen and we'll do ls to see what is created. So we have package.json created now. Our next objective is to go and install Couchbase. Couchbase is a database which keeps track of all the transactions that you are doing. So we'll go and we'll add this dependency as well. To do that, we'll be using sudo npm install Couchbase --save. When we specify this, it will add this dependency to package.json. We'll press enter. We have to specify the password and we'll press enter. After specifying the password, once we will press enter, it will go and it will fetch Couchbase from the repository and it will install it. We'll wait for this installation process to get over. Once it is installed, we will go and now we will plan to have frameworks which can take responsibility of accepting and validating the request data. To do that, first we'll clear screen. And after clearing screen, we will install the necessary packages that can take responsibility of collecting and validating the request data. One of them is Express, then we have Body Parser, and we have JOI package. We'll install them. To install, we'll write sudo npm install. First, we'll install Express --save. Like any other Node.js package, it will connect to repository and it will install Express. Now, once Express is installed, we can go and we can install Body Parser. To do that, again, we'll be using sudo npm install Body Parser and we'll specify --save and we'll press enter. It will connect to repository and it will install Body Parser. Once Body Parser is installed, we can go and we can now install JOI. To install JOI, we'll be using sudo npm JOI. Before writing JOI, we need to ensure that we are writing install JOI and save. Press enter. Now we'll clear screen. So we have set up the basic frameworks which are required in order to build the request and validate the request. We know that public Bitcoin nodes uses promise wrapping packages. So they also need to be installed. To install that, we'll be using sudo npm install. We'll specify request and request promise. For synchronous and asynchronous management of request, we'll specify promise and we'll specify --save. We'll press enter. NPM will connect to its repository and it will get request and request promise, which will enable communication to be synchronous and asynchronous. Now, once we have installed request promise, we can see that it uses Bluebird, which is used for asynchronous communication. Now we have to install Bitcoin specific libraries, which helps us to create wallets, sign transaction, and we also need to ensure that we have the library that allows us to generate a seed which can be used for our HD wallet keys. We'll go and we'll install it. In order to install Bitcoin specific packages, we need to also ensure that we have installed UUID, which probably will be used with Couchbase. So to do that, we'll be writing sudo npm install UUID --save. So now we have UUID also installed. We'll clear screen. And finally, we will be installing Bitcoin lib and Bitcoin mnemonic, which helps us to generate a seed and also create wallet and sign transactions. To do that, we'll be using sudo npm install Bitcoin lib followed by --save, and we'll press enter. Instead of using Bitcoin lib, we have to use Bitcoin core. We'll be using bitcore lib. And we'll press enter. We need to ensure that we get track of the right packages which are available in NPM repository. And finally, we will be installing Bitcoin mnemonic. To do that, we'll keep Bitcoin core, and instead of lib, we'll change it to mnemonic, and we'll press enter. Now we have all the dependencies installed. Once all dependencies are installed, we'll open the package, which is Node app in IDE. To do that, we'll click on open folder. We'll go to user and we'll select the folder which we created, which is Node app. We'll click on OK. Once we'll click on OK, it will load that particular folder in our IDE so that we can go and we can write logic. It has added all the Node modules which are required for developers to start writing application. Apart from that, it has also added package.json, which provides dependencies. So you have all the dependencies which we have installed listed in package.json. This verifies that your development environment is set, and now you can go and start writing applications using these APIs to connect, create, and communicate with Bitcoin. Objective of this video is to demonstrate how to implement blockchain using Java. In order to implement blockchain using Java, we'll be taking an example of Bitcoin. In order to implement Bitcoin using Java, we depend on certain libraries, certain jar files, which are distributed by various providers. For example, we have Bitcoin J, which is used in order to help us in working with Bitcoin. It provides us capability of not only working with setup, but also address key features like wallet API. It also facilitates us with handling events, receiving money, sending coins, customizing the sending process, and also setting up the fees. In this demonstration, we will go and we'll set up our Java project so that developers can utilize this project to extend and write applications which are beneficial for Bitcoin users. Our first step is to go and launch Eclipse. Once you will launch Eclipse, which comes in different flavors, we are using Spring Tool Suite here. We have to go and we have to create a Maven project. To create a Maven project, we'll go to File, we'll select New, and from the list of project types, we'll select Maven project. Once we'll select Maven project, it will ask us to specify certain customizations that we need. We'll keep everything default and we'll click on Next. Once we'll click on Next, it will present us with catalogs. We'll keep default and we will ensure that we have selected the basic one, that is Quick Start, and we'll click on Next. Once we'll click on Next, it will download the required repository and it will ask us to specify group ID. We'll specify group ID as blockchain.bitcoin artifact ID. We'll specify Bitcoin and we'll click on Finish. Once we'll click on Finish, it will create the Maven project. After creating the Maven project, we'll find that Maven project is present in Package Explorer. It creates a pom.xml. We'll double click on pom.xml and we will launch Pom Editor. Now we can see pom.xml, which is one of the tabs which is present in Pom Editor. In case if editor opens in overview, you need to ensure that you are clicking on pom.xml tab to get the XML view. Once you get the XML view, you would like to add the dependencies, which Maven will use in order to build the project by adding various components and dependencies which are needed to develop Bitcoin-based applications. We'll locate Dependencies tab, which is there in line number 17 here, and we'll go and we'll enter some of the important libraries which are required in order to start developing Bitcoin applications. We can go and we can take up one of the dependencies and we can write dependency opening, dependency closing. Group ID is org.bitcoinj. Artifact ID is bitcoinj core. And version that we are using is 0.14.7 and scope is compiled. We'll save the project. Once we'll save the project, we'll find that Maven starts creating the project, pulling various dependencies which are required to ensure that we are able to develop applications using Bitcoin. We'll wait for this operation to get over. In order to track progress, we can go to the bottom right and we can click on the green bar. It shows us what's the progress. Once you find that it's downloading now some of the library, once you get a message saying no operation to display at the time, and you find here task completed, you can go to Maven Dependencies, which is there under Package Explorer. You can click on Maven Dependencies and you'll find that it has added Bitcoin Core, which contains various different packages that helps you to manage different facets of applications. For example, if you want to manage wallet, you can go and click on wallet. And you'll find basic keychain, coin selection, coin selector, key bag, keychain. All these different classes are useful in order to work with wallet. Similarly, you have scripts. You can go and you can see it has built-in scripts which can be used in order to do casting or to minimize the task that developer would need to do whenever there is a signature available. So for example, you can create multi-sig output script or you can create input script. Each one of this class has relevance depending on type of activity that you want to do. For example, you have payments. It provides you capability of specifying the payment protocol. You have different MIME types for payment. You have payment acknowledgement, and you have payment request. These are three different types of payments which can be invoked. Then you have create payment acknowledgement, create payment message, create payment request, create payment request passing different parameters. You can simulate a client and you can write entire client by just using Java. Objective of this video is to specify the regulation landscape and the governance policies governing blockchain. Blockchain provides various integral compliance benefit and Bitcoin utilizes it. For example, data saved into the chain cannot be changed or deleted. So it ensures that once transaction has been done or completed, it cannot be tempered again. Blockchain's immutability also lends proof of process for compliance. So as a technology, blockchain has itself ensured that whatever data is made available as transaction in block is never changed, and it maintains complete history of it, which provides compliance adherence with various compliance policies. Blockchain plays an important role in know your customer and also anti-money laundering. It keeps track of every transaction that happens and it cannot be reversed back. Another important benefit is it provides digital identity management grid, which can be utilized in order to digitally sign and also verify the user in order to ensure that internally we can mine it and find out fraud or any transaction which is not as per the compliance. Recording data is what is important, and blockchain provides all the necessary data which can be recorded, and it is made available in shared ledger. That too, it is near real time, which in fact is better than any other financial settlement system. Now let's talk about some of the technologies which are providing contribution in compliance and regulation management. Distributed ledger technology, which was adopted by blockchain, plays an important role by ensuring that your transactions or blocks are distributed across network, and with immutability feature, it is made secure. Regulatory reporting is also possible by using concept of mining and preparing reports on a regular basis, where you are assured that data might have not been tempered or it might have not been changed. So you can adopt regulatory policies for preparing various reports and sending it to the concerned regulatory body to ensure that those transactions are marked and they are reported. Blockchain internally manages crypto technology to identify transactions. It ensures that faster identity check can be done on every transaction, and we can also go and revert back and identify the root of the transaction. Whenever we talk about two parties doing trade with each other, there are certain regulations, certain agreements which need to be in place. Using smart contracts, one of the technology adopted by blockchain, can digitize these agreements and these rules. Now let's talk about all the contributing technologies which actually are useful and makes blockchain as a popular choice for implementation in financial and other domains. Immutability of data, security that is integral, it's programmable, distributed in order to take benefit of ensuring that data is distributed across multiple peers, time-stamped in order to ensure that we are able to identify the time when that transaction happened, keeping users' details secret, and also unanonymous. These features adds capability in blockchain to ensure that it meets all the compliances and regulatory norms which are created for different domains. There are three participants who are involved. One is banks. In this particular scenario, we have blockchain, which contains all the blocks and also identity. And then we have certificate, which plays important role. So you have device which contains your app through which you are going to invoke the transaction. Each user will have their own seal, which can be made available in form of QR code, which contains ID information. Without revealing information about client, transactions can be invoked. And once transactions are completed, they are sealed in blockchain and they are not open for further modification. This makes every transaction secure and reliable in blockchain.
Objective of this video is to illustrate the impact and the benefit afforded by blockchain for business. In order to evaluate what benefits blockchain brings to the business, we need to understand that what all can impact industry. Better transparency can bring in faith in the business, and blockchain, by keeping transaction histories, provides that particular flexibility in order to have distributed ledger which keeps track of all the transactions. Second important aspect of success of blockchain is enhanced security. There are different ways in which blockchain can be made more secure, apart from record-keeping systems. Transactions must be agreed upon before they are recorded, and once they are recorded, they cannot be changed. So it provides better security in terms of having faith in the technology. Third important aspect is traceability. You should be capable of tracing the transactions. If your company deals with certain products which are traded through a complex supply chain, we are familiar how hard it is to trace back an item and its origin. Blockchain provides that capability by ensuring that whenever there is exchange of goods, they are recorded on blockchain. And you'll end up with an audit trail that shows where an asset came from and every stop it made on its entire journey. Another benefit that blockchain brings in business is its capability of increasing efficiency and speed. When we use traditional approach, which is paper-heavy process, trading anything is a time-consuming process. Blockchain automates it and streamlines it by ensuring that transactions can be completed faster and in more efficient way. Last benefit that blockchain brings in is cost reduction. For most of the businesses, cost is priority. With blockchain, you don't need as many third parties or middlemen to make guarantees because it doesn't matter. If you can trust your trading partner, instead you have to trust the data on the blockchain. That provides better reduction in the cost. Bitcoin, which is one of the implementation of blockchain, brings in revolution in industry. With better adaptability of cryptocurrency and also authorization of Bitcoin cryptocurrency to be used in trade has made lots of impact by replacing the current currency with digitized currency. Bitcoin commits better privacy. It provides exclusive privacy features that can make it hard for anyone to link you with your transaction. Bitcoin comes with better interface, which provides flexibility to use Bitcoin resources like Bitcoin wallet efficiently. Decentralization is another benefit that Bitcoin brings. It helps and supports other peers by adopting decentralization concept. Apart from this, there is no third-party interventions. It avoids any third-party interventions, and that makes it more reliable and more trustworthy. Now let's talk about some of the blockchain projects in healthcare. First one is Hyperledger, which supports requirement of DSCSA, which stands for US Drug Supply Chain Security. Hyperledger also outlines steps to build an electronic interoperable system to identify and trace certain prescriptions, drugs, meaning it successfully met not the law, but the operational need of the industry. Second innovative product is Simply Vital Health. It brings different clinical organizations to same platform, where they can view the same data for shared patients. Financial and clinical algorithms which are powered by AI provide certain actionable strategic opportunities for all users. Third one is Robomed Network, which provides effective medical care by connecting providers and patients. It's a decentralized medical network designed to provide the most effective medical care to the patients. Objective of this video is to describe the approaches of facilitating regulatory reporting and implementation of RegTech. Now, there are certain essential components which must be part of reporting. For example, operational inefficiency. It needs to be captured in order to ensure that we are able to tune and improve it. Data management, how data need to be managed, where data need to be stored. When it comes to blockchain, it adopts peer-to-peer. How many peers need to be there? All that need to be decided, and we need to identify the right time when we have to add new nodes. Also keep track of complexity and the changes. Ensure that there is no blow to data integrity. Also capture essential reports that can lead to a measure of reliability. And all this can be done by doing proper analytics. In order to ensure that we are able to identify the right reporting component, there is a technology called as RegTech. RegTech itself means regulatory technology, which was created in order to address various regulatory challenges which can occur in financial services, and that was done through various innovative technologies. Now, we need to understand what is RegTech. RegTech is actually a group of companies which uses cloud computing technology and provides services using software as service with regulatory complexity, and also ensures that we are able to measure the compliance. It emerged as a result of increasing regulatory requirement after financial crisis of 2008. It's a term that describes use of all modern technologies specifically present in cloud to facilitate compliance with regulations. Primary objective of RegTech companies is to ensure that it uses right set of technologies to simplify processes which are associated with measuring and identifying regulatory compliances. There are various important companies which makes part of RegTech, and all these companies are relevant for fintech companies for whom regulatory compliances are essential. Some of the RegTech companies which you will find are present in order to help in compliance, data management and reporting, risk management, and also providing us KYC and AML, which helps us to keep track of fraud. Now it's time to test your knowledge and understanding of what we have learned in this course. In this exercise, you will launch Bitcoin Core, look up for the transactions, and set up development environment using Java. Now I want you to pause this video and attempt all of the exercises and then come back to view the solution so you understand how well you have attempted. In order to launch Bitcoin, you need to ensure that Bitcoin Core is installed. To do that, go to Applications, select Internet. Once you select Internet, you'll get Bitcoin Core. Click on Bitcoin Core to launch Bitcoin Core application. Once you launch Bitcoin Core, you'll find that there are transactions which are getting downloaded, and as of now in this it is 0.04. Total disk requirement would be more than 150 GB. As of now, we'll click on Hide. In order to view transactions, you can go and you can click on Transaction tab, which is present as one of the menu item. We'll click on Browse Transaction, and you will get all different type of transaction which has taken place from this particular installation. You can go and select today, this week, this month, last year, this year, last month, or you can also specify a range. You can select a range. For example, we can select range as 2010. You can also go and select type of transaction that has been done. We can select others, and you'll find that in case if there are certain transactions which has been done, listed here in the client area. In order to set up development environment using Java, you have to launch Eclipse of your choice, select File, click on New, and select Maven Project. Click on Maven Project. It will ask you certain values On the first screen, you can keep everything default and click Next. Then you can select Quick Start, which is the base type that we'll be using to build this particular project. Click Next. Specify an artifact ID. For example, we are specifying here blockchain exercise. Artifact ID we are specifying as exercise 2, and we'll click on Finish. Once we'll click on OK, we'll find that we have exercise 2 created under Package Explorer. We'll go to pom.xml, double click on it to launch Pom Editor. Once you will launch Pom Editor, you'll find pom.xml tab. If it is not open, click on it to open it. After it opens, you can go to Dependencies, which is there here in this particular file at line number 17. You can go and you can enter dependency which is required in order to build a Bitcoin project. We can write certain statements. For example, we can write here dependency. Within opening and closing of dependency, we can take group ID. Second important tab, mandatory tab, is artifact ID. Then we can also go and take version. Apart from version, we can also go and take the scope. And then we can specify the values. Scope that we are taking here is compile. Version that we are going to specify is 0.14.7. Group ID that we are going to use is org.bitcoinj. org.bitcoinj, and artifact ID which we are going to use here is bitcoinj core. Once we enter these details, we'll go and we'll click on Save. Your project will start building. You have to go and verify. To verify, go to Package Explorer and under your exercise 2, click on Maven Dependencies to expand it. And you'll find all the relevant libraries which are required to write Bitcoin applications are added. Objective of this video is to describe the concept of smart contracts in blockchain. Whenever there is interaction which is needed in order to conduct a transaction between various parties, you would like to have some contract. Smart contract is something similar to the physical world paper contract. It takes responsibility of digitizing the contract, specifying all different rules which can be written using code. In short, smart contract is a program that stores rules and it is placed inside blockchain. This particular piece of code stores rules for negotiating the terms of an agreement. For example, if you have to go through entire documentation of buying a property, that can be specified in a smart contract which can be digitized and can be executed, saving lots of time in order to complete the transaction. This transaction, which is conducted using smart contract, provides automatically verifiable fulfillment. And this is what is something which is gaining speed in adoption of Ethereum smart contract in order to ensure that multi-party, untrusted domain and untrusted participant can come closer, can execute agreed terms. Now, there are various different architectural components which can be used in order to implement smart contract. One of them is Bitcoin, followed by Ethereum and Hyperledger. Bitcoin provides smart contract only from perspective of currency, and it provides support to certain contract languages like Ivy Lang and Belzac. Whereas Ethereum is a comprehensive tool which can help you to not only write smart contract for currency, but spans across verticals like financial domain, medical science domain, clinical research domain, and others. And it does it by providing a flexible language similar to JavaScript called Solidity. Hyperledger Fabric is also smart in building smart contract, where we can use flexible languages like JavaScript and Golang. Now, why do we need to implement smart contract? One of the features is reliability. It is designed and implemented within blockchain So it contains implicit benefits of blockchain like immutability and distributed concept, where immutability ensures that data is never changed or is never tempered, whereas distributed provides capability of having similar kind of ledger across the network. Now let's discuss a particular behavior. We'll assume that independent storage is created whenever an individual A or B wants to put some value, but they cannot liquidate or withdraw them easily until and unless smart contract has not been fulfilled. For example, if A puts rent money in the storage, B will enter the address and the code of the apartment as part of the contract. B gets payment confirmation and A receives the address and the apartment code. But yes, as of now, there is no actual transaction which has happened. Now, assume that A arrives in the city, but B has not provided the correct address. If he has provided the correct address, he'll get the payment, else money will go back to A. Alternatively, if A doesn't arrive in the city, B gets their liquidated damage payment and A gets the rest. At end of the agreement, the smart contract is considered fulfilled and still remains stored in blockchain network for further analysis or verification. In short, when we want to utilize smart contract in our businesses, there are various benefits that it offers. One is direct customer interaction. Fraud potential is reduced. It's cost effective by minimizing the round trip transactions. Immutability further adds value. Record management and resistance to failure are other benefits which can be utilized when you are going with smart contract implementation in your blockchain. Now, smart contract has been used everywhere. For example, in banking, fund transfer is a classic case where smart contract can be utilized. Then you have healthcare, you have supply chain where you have multiple participants who need to be part of the transactions, and in order to ensure that all of them are following the right policies, we can go and we can write smart contract for that. Legal issues. In legal domain also smart contract is playing important role and reducing chances of fraud. Real estate is another classic case where you need to go through sales agreement, sales deed, and also rules and regulations that real estate industry has to follow. Everything can be automated by using smart contracts. Government is also utilizing capabilities of smart contract in scenarios like where it has to award various contracts to contractors. They have to go through strict verification process and they have to adhere to certain rules which can be implemented by taking benefit of smart contract. Internet of Things, where multiple devices have to interact with each other and they need to have proper governance and coordination. Smart contract can play a major role in IoT domain too. Objective of this video is to illustrate architecture of Ethereum. There are various important elements that we need to understand in order to derive Ethereum architecture, out of which account type, network nodes, transactions, messaging, gas, all these are important components that we need to understand in order to start utilizing Ethereum. From perspective of account types, there are two types of accounts which exists in Ethereum. One is externally owned account and second one is contract account. In order to differentiate between external account and contract account, we need to understand that externally owned account will have Ether balance. It can invoke transactions, that is, it can transfer Ether, or it can also trigger contract code. External accounts are typically controlled by private keys and it has no associated code. But when we go with contract account, similar to externally owned account, a contract account also has a Ether balance, but unlike external account, it do have associated code. This code execution is typically triggered by transactions or messages whenever it is received from other contracts. Whenever we execute contract, it takes responsibility of manipulating its own persistent storage. In other words, fundamental difference between external account and contract account is contract account will have code associated, whereas externally owned accounts will not have any code associated with them. Now, other important element which plays important role in setting up architecture of Ethereum is full node and lightweight node. In order to understand full node and lightweight node, we need to understand that a node is any computer that is connected to a cryptocurrency network. For example, you can have any computer that is connected to Bitcoin network. It can be considered as Bitcoin node. Similarly, any computer which is connected to Ethereum network will be considered as a node. There are different type of nodes which exist. One is full, second one is lightweight. If we think from perspective of full node as something which can have a transaction output, it can also have transactions and blocks may only release certain number of coins as a block reward. When it comes to lightweight nodes, there are certain full nodes which also serves as client, and these are known as lightweight client nodes. Responsibility of lightweight client node is to verify the transaction, and internally it can use various methods. For example, one of the methods can be simplified verification method, which allows a node to verify whether a transaction has been included in a block or not. So when we are planning for Ethereum architecture, we need to understand and we need to identify the behavior of account and behavior of nodes. Now let's try understanding what is content of Ethereum virtual machine. Ethereum virtual machine takes responsibility of executing your contract code, which is written using Solidity. Whenever you want to implement a contract, you will be using Solidity as a language to write the code, which will implement the contract. It will be compiled using Ethereum compiler. After compilation, it generates Ethereum bytecode, which will be used in order to build a contract which will be written in Ethereum virtual machine, which will contain various blocks. These blocks will in turn have the contract with them. So whenever we are thinking about writing a contract, we need to ensure that we follow approach of ensuring that we have the compiled code in form of bytecode, which can be integrated inside Ethereum VM, specifically in blocks in order to implement the contract. Now let's understand what is Ether and gas. Ether can be treated as the coin, and gas as a charge, which every node participating in the network will incur. So we can say that gas is typically the name of the execution fees that sender of transaction need to pay for any operation made on Ethereum blockchain. Gas is inspired by the view that these fees act as crypto fuel, driving the motion of your entire smart contract. You have certain identifiers, certain attributes which are associated with gas. For example, you have a gas limit, then you have gas price, and you have gas fees. In short, gas and ethers are decoupled since unit of gas is aligned with the computation unit that will have a natural cost, while the price of ether generally fluctuates as a result of market force. So you can say that value of your currency is ether and gas is the charge that will be applied on a particular transaction. So you have different units of gas. You can see WEI, KWEI, which stands for kilo, M is for mega, G is for giga, and then you have ether units also. For example, you have micro ether, you have milli ether, and you have ether. So these are different units which can be used in order to derive a value of ether and gas. Now, another important component of Ethereum is mining. Whenever we talk about mining, it is something deriving value. In other words, from perspective of Ethereum, mining is the way to secure the network by applying certain mechanism on it. For example, you can secure your network by adopting approach of mining, which takes responsibility of creating, verifying, publishing, and propagating blocks in the blockchain. In short, when we talk about mining, it gives us mining ether, which is similar to securing the network after verifying the computation. For example, assume that A attempts to send B some ETH. Now, A and B transactions are combined together with other transactions that might have occurred since the last block. It is responsibility of miner now to compete to verify the block, which it does by following and adopting a proper verification process. Once verification is done, victorious miner creates a new block and gets rewarded for it. Finally, with the transaction verified, B receives the send it from A. We can see that mining plays a very important role in terms of building a consensus between different parties. Now let's take an example of crowdfunding, where you will have financial institutions issuing certain funds. So we can go and we can derive a particular approach in order to implement crowdfunding. For example, you will have funding issues in the initial stage. Then you'll have a DAO which is set for crowdfunding. Once setup for crowdfunding is done, you will have contracts that need to be set in order to ensure that proper conditions and rules are applied to simulate the crowdfunding autologic. Once this contract is written, you will have donors for whom there will be tokens which will be issued. Finally, donors can donate funds through a contract which will be recorded in blockchain. Once it is recorded in blockchain, it is never changed because by default it is immutable in nature. This cycle goes on and you'll find that you have automated and decentralized crowdfunding by using blockchain approach where you can write smart contract using Ethereum. Objective of this video is to specify the essential differences between Bitcoin and Ethereum. In order to evaluate and understand difference between Bitcoin and Ethereum, we need to understand that Bitcoin is typically pitched as an alternate currency, whereas Ethereum comes into play when we want to digitize the contract. Ethereum provides you capability of having peer-to-peer contract setup, which can be done among various untrusted parties. So elaborating Ethereum is just more than money or currency because it comes with certain exclusive features which you will not find in Bitcoin. For example, its smart contract, EVM, that is Ethereum Virtual Machine, and support to Solidity. And it can also be used as currency by using Ether, which is implemented for peer-to-peer contracts. So whenever we talk about differences between Bitcoin and Ethereum, we can say that Bitcoin is a stable digital currency, whereas when we talk about Ethereum, it is more about smart contract applications. So we need to identify the use cases clearly, and we need to utilize these two blockchain technology efficiently. So in short, Bitcoin is a digital currency, whereas Ethereum plays an important role of building smart contract applications. Now let's compare both of them from perspective of technology. Currency issuance, when it comes, Bitcoin is 12.5 new Bitcoins every 10 minutes is what is issued. Whereas when we talk about Ethereum, it is 3 new Ethers every 15 seconds. Now from perspective of currency cap, Bitcoin has limited it to 21 million Bitcoins, and out of which 17 million Bitcoins are created so far. Whereas Ethereum has no hard cap currently. Roughly 100 million Ethers are created as of now. Now from perspective of how frequently new blocks are created in Bitcoin and Ethereum, when it comes to Bitcoin, new blocks every 10 minutes, whereas Ethereum, new blocks are created every 15 seconds. From perspective of language support, Bitcoin has built-in but very limited language functionality, whereas Solidity is a strong language which helps us to write smart contracts. When we talk about costing is based on gas in case of Bitcoin, whereas Ethereum simply depends on size. Now, what is the block size in case of Bitcoin? It is 1 MB, whereas Ethereum is much larger, it is 15 MB. From security perspective, when it comes to implementation of hash algorithm, Bitcoin supports SHA-256, whereas Ethereum provides support to KEC-CAK-256. adopted algorithm for consensus in case of Bitcoin is proof of work, whereas in case of Ethereum, it is not only proof of work but also proof of stake. Now let's talk about additional features of Ethereum, which you may not find in Bitcoin. One of the features which is not implemented exclusively in Bitcoin is smart contract with selective cryptocurrency. Then in case of Ethereum, you don't need Kickstarter if you have Ethereum. Apart from this, you can also replace traditional management structure with democratic autonomous organizations by using smart contract feature. Another benefit of Ether is its support has been increasing. You'll find various different companies from fintech as well as from technology domain which has come forward in terms of implementing Ether as one of the smart contract implementation in various domains. Objective of this video is to list various essential technologies and tools that are used to implement Ethereum. Now, if we want to develop Ethereum blockchain applications, we can use various tools which are provided in Ethereum ecosystem. For example, Ethereum itself is a smart contract blockchain on which we can build various decentralized applications, and these are typically called as smart contract. Now, when we talk about client, we can have Git, which works as an official client software, which is provided by Ethereum Foundation itself. It is written using proactive Go programming language, and you have various components which comes along with Git, like you have client daemon, you have Git console, which provides you a command line tool using which you can connect to all the running nodes, and you can do various actions like you can create and manage node, you can also query the blockchain and do transaction management. Then you have Parity. Parity is an implementation of Ethereum protocol. It is written using a specific language called as Rust programming language. But yes, it is unofficial client and it is maintained by a third party company called as Parity Inc. Then we have Web3.js. In order to ensure that we are able to communicate with Ethereum node using JavaScript, we have a library called as Web3.js, which can be used in order to interact with the node using JavaScript. This also enables you to communicate with your node with any application which is built using JavaScript, typically in form of web applications. Solidity is most popular programming language which has been used in order to write smart contract which runs on Ethereum blockchain. It is a high-level language which compiles the code and get converted to EVM, that is Ethereum Virtual Machine, and code that it is converted to after compilation is called as bytecode. It is similar to Java and various languages like Scala, Groovy, Clojure, JRuby, and others. Now we need to have a framework which helps us to develop applications for Ethereum. Truffle and Embark. These two are most popular frameworks which are used to develop applications. They take responsibility of abstracting all the complexities of compiling and deploying contract on blockchain by providing a simplified framework. So in case if we want to develop Ethereum dApp applications, we can try out with Truffle and Embark. Now, apart from this, we do have certain other technologies that we can use. For example, we can use MetaMask, which is a Chrome plugin that can be used to interact with Ethereum node. We have ENS, which is Ethereum naming system, something similar to DNS for network. ENS is used in Ethereum in order to define naming system for nodes. You can go and you can map any Ethereum contract or wallet address to a human readable name, and that's what is the objective of ENS. Now, when we talk about blockchain, it works good when amount of data is small. But when you have to work with domains where data is huge, for example, in case of medical domain, you have to store patient record and probably it can be a huge file. Similarly, when we talk about sale deed, it can again be a huge file. So it is expensive and also not scalable to store a blob in blockchain. In order to resolve this problem, we can go and we can use a decentralized content storage and distribution service, which is provided to us by Swarm. Another solution for decentralizing your content instead of storing it in a single blob, we can also go with interplanetary file system, that is IPFS, which is similar to Swarm. It is a decentralized storage system. It is no way related to Ethereum directly, but we can go and we can integrate with existing Ethereum network. Now, one of the communication protocol for dApps is Whisper. We can go and we can implement Whisper as one of the protocol which can be used in order to implement communication among different dApp applications. So by using all these tools, we can increase the productivity and also time to market our Ethereum product, which contains various smart contracts. Now let's put all the tools together. We have divided it into 3 different blocks. One is ETH network, which contains Geth, Parity, MetaMask, and also deployed contract, which is managed by ENS in order to provide a name. We can also go and use Chrome browser powered by MetaMask plugin in order to simplify the way we manage our Ethereum network. Then we have contracts, which can be divided into 2 different types. One is we can use IPFS. We can also use Swarm in order to provide decentralized storage and manage huge chunk of data which may be required in your Ethereum ecosystem. Finally, in order to conclude, when we set up our development environment, we work with mixed resources. It's not necessary that you have to go with all the resources. You can go and you can identify what fits into your implementation domain. For example, one of the combination can be Whisper for communication, developers tool, different type of wallets, and info sources. Apart from that, you can also utilize forums to get suggestions and also involve community in order to help you in bringing a productive Ethereum network. Objective of this video is to describe role of smart contracts and its relevance in Ethereum. Ethereum provides an exclusive feature which takes it ahead of various other blockchain implementation, and that is the way smart contracts are implemented. Smart contracts are rules which are digitized in order to bring up the contract among various untrusted parties. It is treated as a standard contract which outlines the terms of a relationship among various partners and parties involved in transactions. In order to ensure that we are able to implement compliances and regulations in terms of relationship depending on the domain, we can enforce relationship by using cryptographic code which is provided by smart contract. Smart contracts are not physical, they are digitized. In other words, they are programs which executes exactly as they are set up to do. So there is no question of tampering, and it also ensures that there is control over frauds. Users can create contract, they can push data to contract to execute the desired command, and all this is done by generating a bytecode which is compiled code in case of Ethereum, which is made part of a block which sits under Ethereum virtual machine. Now, from perspective of smart contract and Ethereum, when we talk about its comparison, Bitcoin was the first to support basic smart contract, but it was limited only to currency. Whereas Ethereum provides capability of implementing smart contract not only in terms of currency, but also in terms of various contracts and regulations which can be set among untrusted parties. So it's a platform which specifically uses smart contract tools in order to build smart and rich contracts among various parties. Ethereum also provides benefit by replacing Bitcoin's restrictive language by providing a much better and comprehensive language that can be used by developers to write programs. Now let's talk about some of the additional features of smart contract, specifically when implemented with Ethereum. It provides you capability of implementing multi-signature accounts where funds are spent only when a required percentage of people agree. And this helps in making an organization more democratic. Smart contract can also manage agreements between users by providing utility to other contracts. Apart from this, it also stores information about an application. So for example, if you want to go with domain registration information or membership record or onboarding a buyer or a purchaser, we can use smart contract to ensure that entire onboarding process is automated and is as per the rules and governance policies. Benefit of smart contract on blockchain is its self-execution. For example, assume that there are two people called as Amber and Max. They want to do a transaction in terms of selling up a property or settling the claim. So Amber will write a will using smart contract where she can specify insurance claims, trade and investments, buy, sell car, homes, settlement of property and will, marriage, divorce, and various other features which can be termed in terms of agreement. And by using self-executing smart contract, there are less chances of any fraud and transactions will be more reliable. Now, how actually smart contract runs with Ethereum? There are various elements which plays important role. One is EVM, which is Ethereum virtual machine that takes responsibility of executing smart contracts. These smart contracts are in form of bytecode, and a series of ones and zeros are part of this bytecode which can be read and interpreted by network. Ethereum takes responsibility of running smart contract when user or other contracts will send the message with transaction fees. It can interact with wallet, and it can ensure that your Ethereum distributed network automates execution of smart contracts, applying some fees in terms of value of the transaction. Objective of this video is to illustrate architecture of Ethereum node. Ethereum network is essential, and Ethereum network may contain nodes where each node can be made available or can be created on a particular system. Fundamental objective of node is to enable communication with blockchain. It requires a blockchain client. Client is a piece of software which is installed on a particular computer, and this software is what makes that particular computer an Ethereum node. There are various ways in which we can use nodes. For example, nodes can be used in order to enable peer-to-peer communication with other clients. It provides you capability of deploying and interacting with smart contract. It provides benefits by providing you multi-signing capability. It also has one-to-one and broadcasting of transactions. And apart from that, for verification of transaction, it can use mine. In order to enable all these tasks, you can have different type of nodes in your Ethereum network. For example, you can have full node, you can have archive node, and you can also have lightweight node which takes responsibility of verifying the transactions. Now, how to communicate with Ethereum nodes? In order to communicate with Ethereum, you can use a language called as Get. It's a specific software which is provided by Ethereum Foundation. Internally, it is written in Go programming language. It contains three important components. One is client daemon. So when you start your client daemon, it takes responsibility of connecting to other clients. And these clients are typically called as nodes. After connecting, it downloads a copy of the blockchain. And post that, it will communicate with other nodes to ensure that copy of blockchain is up to date. It also has the ability and capability to mine blocks and add transactions to blockchain. Apart from adding transaction to blockchain, it can also validate the transaction in block and also execute the transaction. Second important component of Get is Get console, which provides you command line tool. Using this command line tool, again, you can connect to any running node and you can have control over transaction management, account creation, and also querying the blockchain. And in order to diversify and provide you another different kind of client where you can use graphical user interface, we can go ahead and we can utilize Mist browser. So Mist browser can do anything whatever Get console can do with typical graphical user interface. Now there are various popular client and languages which can be used by Ethereum blockchain network. For example, you have Parity, which is a third-party framework. Then you have Get, you have Get Node, and you have Get console along with Mist browser. You can use combination of various different clients in order to manipulate and manage your Ethereum blockchain effectively. Get uses Go while Parity uses a language called as Rust. So these two are popular tools which are used in order to control and manage your Ethereum blockchain network. Now let's talk about how to install and manage Node using Get. Installation is pretty simple. You can install it on various platforms which includes Windows, Linux, macOS, Ubuntu, and others. You have to just go and get https install getethereum.org, and you can use Bash. Depending on your operating system, you can go and you can download Get. After downloading Get and installing it, depending on installation steps which you have to adopt depending on your operating system, you have to run Get. There are two different versions in which you can run. One is Get, second is Get Lite. Now, once you have started your Get service, you can access your Get console by using Get Attach. By using Get, you can also represent the block number of your Ethernet network by manipulating a property called as web3.eth.blocknumber. Now, how to create a new account? You can create a new account by using Get Account New. On macOS, this account will be created and it will be stored on library Ethereum. On Linux, it will be there in .ethereum at the root. And in Windows, it will be stored at app data Ethereum. So these are different locations where you will have your accounts created and stored. Now, if you want to utilize Get to be accessed from other clients, you have to start Get. Once you'll start, client will automatically start an RPC server at a port called 8545. Now, once it opens that port 8545, depending on the installation and the port assignment by your system, now you can go and you can access this RPC server by connecting to IP address, which in this case is localhost, with various libraries including web3.js or web3j, or you can also manually call it by using curl or wget. Not only that, you can also collect the output from the console and you can log it or redirect it to any other file. And to do that, you'll be using command called get console to, and then you can redirect it to get.log. Monitoring is another feature which will help you to collect information from logs. You can monitor the log by opening a different window, and to do that, you can use tail-f get.log. Objective of this video is to recall various programming languages which can be used to define smart contracts. Smart contract can be written using various languages. One of the languages which is adopted by Ethereum is Solidity. Solidity provides you capability of writing comprehensive smart contracts, giving flexibility to the developers by providing various libraries. It is similar to JavaScript, but yes, it is saved with .sol extension. Another option that we have is Serpent, which is Python-like, where it is saved with extension called .se. Then we have LLL, which is based on Lisp. So depending on the developer's community and familiarity with the languages like JavaScript and Python, one of these languages can be selected in order to write smart contract. Now let's take a case of simple smart contract for storage. We are defining Pragma Solidity along with the version, and then we are creating a contract, and this contract is for storage. We are giving a name to the contract called simple storage, where we are defining a storage unit that is store data. Apart from that, we are defining set and get, where one function will take responsibility of setting value to your unit that is store data. Another function will take responsibility of getting the value from the store data. Then let's take a complicated example of currency, where we are defining a contract called coin. And this contract called coin is having a constructor called function coin, which actually sets a minter value. Then we have functions like mint for mining and send for sending, where we are checking the balances and we are emitting the mint. We can also have various events which can be added to this particular contract called coin. For example, one of them is event send. This can be utilized in order to exploit and log messages whenever there are change which happens because of this send on the data. So there is another compiler called as SOLC compiler, which is derived from C++ libraries, and it is used in order to compile contracts which are written in Solidity. So in other words, in order to generate the bytecode, we can use SOLC compiler. We can also use browser-based compilers in order to simplify and make the development more robust, and one of those compiler is Cosmo. Then we have another approach where we can write contracts from our web applications by utilizing web3.js API. It can be used in order to code smart contract, and also it can be used in order to interact with contracts to build distributed apps. Now, once your Solidity contract compiles with SOLC and sent to the network, we can call it by using web3.js API as client, which can be built using various web applications. So whenever you want your application to interact with the contract, we can go ahead and we can use web3.js API. Now let's talk about some of the frameworks for dApp. You have Truffle, you have Embark, and you have Meteor and APIs. So by utilizing these frameworks, we can go and we can simplify the way smart contracts are created. For example, instead of handling complexity, we can generate the entire directory structure by using Truffle or Embark as a framework. Now, taking an example of front end, if we see here, we have divided it into three parts. One is Ethereum network, which contains your consensus, web3.js, and Solidity contracts. Now from front end, you can go and you can utilize dApp functions to push compiled contract onto the network, and that is responsibility of Ethereum node. Finally, you would like to have a secure and crypto secure front end, and to do that, you are defining a key store where front end can make call to contract on blockchain, and all these transactions can be signed in Ethereum node by using Web3 API. So by utilizing various components, we can go and we can not only write smart contract in robust way, but also we can access those contracts by utilizing APIs like web3.js. Objective of this video is to demonstrate the steps involved in setting up the Ethereum development environment. In order to start setting up development environment for Ethereum, we need to ensure that we have our virtual box ready. We have a virtual machine, and that virtual machine name is blockchain. We have to go and we have to specify the password in order to get into the box. After writing your password and pressing enter, you'll find that it launches the desktop of Ubuntu, and you'll find a terminal as well. In case if terminal is not there, you can launch a new terminal by pressing Ctrl, Alt, and T. You'll find that it launches a terminal. We'll close the new terminal which is launched in order to work with one of the terminal, which can be either previous one or the new one. There are certain dependencies which we need to meet in order to install Ethereum development environment. We have different tools which can be installed. For example, we can use Ethereum JS test RPC that provides us capability of testing and developing Ethereum clients. Apart from that, we do have another tool called as Truffle, which is a development environment, testing framework, and provides asset pipeline for Ethereum with basic objective of making Ethereum development simple and easier. So let's go and target first dependencies. First dependency that you need to ensure that you have installed is Node.js. So you need to ensure that you are installing Node.js and try to get the latest version always. So for example, in order to get Node.js installer, what we can do is we need to go and install curl. So in order to install, we'll be writing sudo apt install curl and you'll press enter. Now you have to specify the password. You are specifying the password because all installation that we will be doing will be as a super user. So you need to ensure that you are specifying the password. After specifying password, press enter. It starts installing curl utility, which we will use in order to fetch different installation packages. Now once curl is installed, you can test whether curl is successfully installed or not, and to do that you will just write curl and you'll press enter. And you will get a suggestion from curl saying that specify curl -- help or specify curl -- manual for more information. This indicates that your curl is installed successfully. Clear screen. Write clear screen in order to ensure that you move again at the top and all previous history is deleted. Now let's go and fetch Node.js setup file. In order to fetch it, we'll be using sudo followed by curl and we'll specify -sl as one of the arguments and we'll specify the URL of Node.js installer. Since we are using Ubuntu, we'll be using deb.nodesource.com and here you have a file called as setup-6.x. You have setup_6.x. You can directly move to bash by writing sudo specify -e and bash followed by a -sign. Press enter. Once you'll press enter, it will start installing node source, that is Node.js. It will populate all the apt-get caches in order to ensure that you get all the libraries which are required in order to finalize the installation of Node.js. Now once it is done, we can go and we can install Node.js. In order to install Node.js, we'll be using sudo followed by apt-get followed by install followed by -y and specify tool that you want to install. We want to install Node.js, so we have specified here Node.js. Press enter. So it reads from apt repository and it tries to install Node.js on your current system. So once you have installed Node.js, in certain scenarios, you'll find that it also installs npm. In order to check whether it has installed npm or not, we have used a command called npm -v. We can also check our node version by writing node -v, press enter, and you'll find that it has installed node v6.14.3. Now once your Node.js and npm are installed successfully, you can go and you can install development tools. For example, first tool that we are going to install here is Ethereum JS Test RPC, which is used for testing and development. In order to install that, we'll go and we'll first install Build Essentials. To do that, first we'll clear the screen. In order to install Ethereum JS Test RPC, we need to ensure that we are installing Build Essential. Build Essential will be used in order to further install Git, which is required in order to fetch Ethereum JS Test RPC. To do that, we'll be using sudo followed by apt-get followed by install and specify name of the tool, that is build essential, and press enter. Once you'll press enter, it will start reading build essential. In case if it is already installed, it will give you notification that build essential is already installed. Now our next objective is to go and install get. To install get, we'll be using sudo apt-get install followed by git, that is get, which is a build tool. It will ask us confirmation for continuing the installation. We'll specify yes and press enter. And you'll find that get is installed successfully. Now next is we have to install the actual development and testing environment. And to do that, we'll be installing Ethereum JS test RPC. We have already installed Git, which takes responsibility of fetching or pulling or cloning from Git repositories. To install Ethereum JS, we'll be using command called sudo followed by npm followed by install -g. -g ensures that your tools are globally available. And then specify Ethereum JS followed by test RPC. And we'll press enter. Once we'll press enter, it will connect to npm repository and it will try to pull the package to complete the installation. It may take some time. We'll wait for install to get over. And now we saw that it's installed and it has pulled in the required packages and dependencies. Once it is installed, you have to go and you have to test it. To test RPC, first we'll clear the screen and we'll go and we'll specify command called test RPC and we'll press enter. Once we'll press enter, we'll find that you have test RPC running at port called 8545. It has generated certain private keys and also certain accounts. So you can see the list of accounts and private keys available when we are executing Ethereum JS test RPC. Along with that, it has started the service, that is HD wallet, at a particular port and IP, and that IP is localhost 8545. Objective of this video is to illustrate the fundamental concept of Solidity programming language. In order to start working with Solidity, we need to ensure that we have installed another developer tool, and that is Truffle. To install Truffle, first what we have done is we have launched our Visual Studio Code so that we can use it as an editor for writing Solidity programs. We'll go and we'll first ensure that all prerequisites are running. We will go to View. We'll click on View and we will launch Integrated Terminal. We'll click on Integrated Terminal. Once we click on Integrated Terminal, it launches Integrated Terminal. If you see, we can launch multiple terminals in the same IDE, which is Visual Studio Code as of now. Our first task is to ensure that we have started test RPC so that we have a test environment ready. To do that, we'll be writing test RPC and we'll press enter. Once we'll press enter, it will show some of the keys which are there along with some of the default accounts. Apart from that, it also tells that it is running and listening on 8545. Now we'll launch another terminal by clicking on plus icon, which is part of the second bar. Once we click on it, we'll find that we have 6 bash which is running. We'll go and we'll select second bash. Now we are there in another terminal. We'll go and we'll complete the installation process of Truffle. To install Truffle, we'll be using sudo followed by npm followed by install. We want it to be globally available, so we'll write -g and Truffle. In case if you're getting some warnings, you can say no to close it for now. Once you have specified the installation command, you'll press enter. Once you'll press enter, it will ask you the password. specify the password, and press enter. It will connect to repository and it will try to fetch and install Truffle. Once we have installed Truffle, we'll clear screen. After clearing screen, we'll create a directory where we would like to write our smart contract in Solidity. To do that, we'll be creating a folder. For example, I'll create mkdir skillsoft 2 and we'll press enter. We'll move into that particular directory by writing cd skillsoft 2. Once we are there in that particular directory, we'll invoke a command of Truffle to create a new app. To do that, we'll be writing Truffle followed by init and we'll press enter. Once we'll press enter, it will create some new folders and files. We'll wait for all the downloads to complete so that all dependencies of a Truffle project are done. Now it downloaded, unpacked, and it has set up. We'll do ls in order to see what it has created. And you'll find that it has created contracts, migration, test, truffleconfig.js, and truffle.js. These are the files and directories which are created by Truffle. We will launch Truffle in the editor. To do that, we'll go to File and we'll click on Open Folder. Once we'll click on Open Folder, it will show us what all folders are there. We created Skillsoft 2, so we'll select Skillsoft 2 and we'll press on OK button. Once we'll do that, we'll find that it closes out all the terminals and it loads the folder. We'll wait for the folder to appear in the editor. Once it appears, you'll find various contracts which are already written, that is migration.sol. Then you have migration, which is initial migration.js file. You have test, and you have truffleconfig.js and truffle.js. So you have created a contract which is created as a result of truffle.init. We can open migration.sol, which is a Solidity file, and you will see that in order to help you in creating contract, it has imported Solidity with an appropriate version, and then it is creating a contract. Name of the contract is migration. Along with migration, it has two attributes. One is address, which indicates public owner, and you have UINT, which is data type public last completed migration. Then it has a constructor and it has some modifier called restricted. Apart from that, it has two functions. One is set completed, where it is taking up an argument called UINT completed, public restricted. And you have another function called as upgrade, where it is passing address new address as an argument. Finally, you are making call to migrations, which is a JavaScript. You are making call to migrations and you are passing the new address. And you are upgrading by making call to a method called setCompleted, passing it the last completed migration. We'll close the marketplace extension as of now. In case if we want to have the extension, we can go to File. Instead of going to File, we can also get it from the icon, that is extension. We'll click here and we'll write here Solidity. Once we write Solidity, we'll find Solidity, Ethereum Solidity language for Visual Studio Code. We'll click on Install. Once we'll click on Install, it will install support for Solidity language, where it will ensure that syntax highlighting is there. Compilation also can be done by just pressing F1. You can compile the current contract. So it provides support to write contracts using Solidity. We'll wait for this install to get over. Once it is installed, we'll close extensions dialog and we'll click on Explorer. Once we'll click on Explorer, we'll get again the folder structure. Now our objective is to go and create a new contract. In order to create a new contract, we have to create a file under contracts folder. So we have contracts folder. Within this folder, we'll be creating a new file. We'll click on new file icon and we'll give a name to this file. For example, hello skill. Let's follow the convention of the file name. We'll write hello skill.sol and we'll press enter. Once we'll press enter, it will create a Solidity file where we can go and we can write our code. So for example, first line should be pragma followed by Solidity and specify the version of your Solidity. So for example, I'll go to migrations and I'll pick up the right version of the current install. We'll move back to hello skill and we'll paste it there. So now we have the right version ready with us. Next, we need to create contract. To create contract, we'll be using keyword called contract, followed by the name, that is hello skill, opening and closing brace for marking the boundary, and then we'll take the attribute. First attribute that we are taking here is address, which is public, followed by creator. Second attribute we'll take is the number, which is UINT, followed by public, followed by my number. Now next is we have to specify the message, and message will be of type string. So we'll take string as data type and we'll specify the access, which is public, and name of the attribute, which is message. So we have created 3 different attributes for our contract. Now our next objective is to go and write constructor for hello skill. To write constructor for hello skill, in Solidity we have a keyword called function, followed by name of the contract, that is hello skill. Ensure that name of the contract is similar to name of the constructor. You can pass arguments as well, or you can pass definite values. For example, I'm populating creator with MSG, that is message dot sender. And we'll populate message with a value that we want. For example, we'll say hello Skillsoft. And third attribute we can specify as my number to be some value. Let's take 10. So we have written now constructor. After writing our constructor, our next objective is to go and specify contract. In order to do that, you can use multiple different approach. For example, you can write functions which will go and tune your attributes. As of now, in order to keep it simple, we'll save the file. To save the file, we'll go to File, Save. Once file is saved, we have to go and we have to edit, deploy contract. So in order to ensure that we are able to edit the file, we'll go and we'll create, in case if it is not present, we'll go to migrations. In migrations, we'll create a file and we'll name that particular file as to_deploy_contract.js. So it's a JavaScript file which takes responsibility of deployment. And now we'll be writing code in order to deploy hello skill contract that we have written. To do that, we'll write var, give a name as hello skill equal to artifacts dot require, and we'll pass here the artifact that we created. We'll take it in double quotes. Artifact that we want to deploy is the name of the file which contains our contract. So it is hello skill.sol. So now we have declared a variable which takes responsibility of loading the contract which is there in helloskill.sol. And we'll be using deployer to deploy it. So we'll write deployer.deploy. And we'll pass here the skill that we want to deploy. For example, we'll write here hello skill. We want to deploy hello skill. This statement has to be written in a particular function call. So we have to build a function call, and let's take that function with module dot exports equal to, we'll take function, and within function we'll pass the deployer. We'll have opening and closing braces to set the boundary of the function. So now we have our module ready, which contains a function which is anonymous, takes an argument, and we use the same deployer which we are passing to this function to deploy skill. We'll save the file. To save the file, we'll go to File and we'll click on Save. So once you have written your contract and once you have written your deployment scheme, you'll be able to deploy it to your Ethereum network. Objective of this video is to demonstrate how to create a blind auction contract for Ethereum using Solidity. In order to implement a blind auction, which is a particular smart contract where we can have an auction, instead of sending a bid, the bidder would send a hashed version of it. Since it is impossible to find two values that are long enough and with similar hash values, the bidder commits to the bid by sending the hashed version. In order to implement this, we can go and we can utilize any ID. For example, we have launched Visual Studio Code and we have created a file called test.sol. Now we have to start writing the auction using Solidity. In order to write your blind auction contract, you have to first ensure that you are using Pragma and you are specifying the Solidity version that you are using. So we'll specify Solidity. We'll say version as /0.4.11. Now, once we have specified Pragma, we need to go and build the contract. To build the contract, we'll be using contract. We'll specify a name called blind auction. We'll set the scope of this blind auction. And now we need to have a structure which will represent the bid. In order to build a structure, we can use Solidity capability and the keyword called struct. So we'll write here struct followed by bid, and you have to specify a boundary to that structure as well. Our bid structure will contain blind bid ID and a deposit. So for example, we can take data types as bytes, 32-bit, and we can specify blind bid. Second important element to this will be uint, and we'll be passing here the amount that need to be deposited. So now we have created a structure which contains two arguments. Now, second structure that we need to create here is the beneficiary address, whoever is the beneficiary of this particular bid. So for that, we are taking address because we are going to create address. We'll take public and we'll give a name. For example, I'm giving name as beneficiary address. After specifying public beneficiary address, we have to go and we have to specify certain other attributes like end bid, reveal bid, and to denote that bid has ended. To do that, we'll take all uint, which is integer, public, and we'll specify end bid. Second argument that we'll specify is again uint and followed by public as the specifier and end RVL. Third important argument that we need here is of type boolean to keep track of the status of the bid. So we'll write public is open. So now we have specified the required argument. we have to go and we have to now do mapping of address with the bids which are available. To do that, we'll be writing here mapping. We'll specify address mapping with collection of bid. So we'll write here bid and we'll take an array. Now we have specified the mapping. We'll give a name to this particular mapping type by specifying public and available bids. So now we have specified bid. We have to go and we have to track who is the top bidder and what is the amount of top bid that has been specified. So to do that, we'll be taking up address again. We'll take public of the top bidder because we need to keep track of top bidder. So we'll take top bidder here and also top bid amount. That is what is essential. So we'll take UINT, we'll take public and we'll take top bid amount. So we have done all the declarations which are required. Now what we need to do is we need to go and we need to trap certain events which are essential in order to mark the bid and the auction complete. So we'll go and we'll take an event instead of function and we'll name this event as auction complete. And we'll pass here what makes an auction complete. So for example, address of the winner of the bid and also the top amount. So we'll write here UINT top bid. So we'll take here top bid. So now we have written an event in line number 21 which talks about what is the status of the bid and what event should be fired when auction completes. Now comes the most important function where we have to specify the blind auction. So for that, we'll be writing a function and we'll name this function as blind auction. And we have to pass certain arguments to this blind auction function. For example, first one will be what is the time of bidding. So we can go and we can take UINT. We can take time bidding. Second argument will be what is the reveal time. So we can go and we can take UINT. We can also specify reveal time. And third important attribute here will be the address of the beneficiary. So we can take address and we can take here ben address, that is beneficiary address. So we have passed the required arguments here to this particular function, and function body will typically contain assignment of these elements to actual beneficiary address, end bidding time and end reveal. So to do that, we'll be taking up beneficiary address equal to underscore ben address. We'll be taking up here end bid, which is equal to whatever is the time now plus what is the time bidding. And third important assignment that we have to do is end reveal, which is equal to end bidding plus your time, that is reveal time. So we'll take here underscore reveal time. So now our function is ready where we have done the assignment. Now we need to place the bid. In order to place the bid, we'll be using another function in line number 42. We'll give a name to this function called function place bid. And we'll pass here bytes 32 with an argument called blind bid, because we are not aware about what is the actual bid value which is being used. Now we have to specify payable and we have to specify a function called before only, and we have to pass here end bid. Within this particular function, we'll pass an object, and that object will contain blind bid, which will be assigned with a value called blind bid. And second attribute of this particular object will be deposit. And this deposit will contain whatever is the message dot value. So we have defined now what is the bid value and how actually this blind bid will be placed. So here, if you see Ether that was sent will only be refunded if the bid was revealed correctly during the revealing phase. So we have here place bid and we are keeping track of the blind bid when it was placed. So by writing these functions which we have written here, we can set the stage of creating a blind auction. And this particular blind auction implementation which is created is keeping in mind Ethereum capability. So whatever contract we have written here also deals with the challenge of combining auction bidding and the blind, which means that we need to make the winner send the value along with the money. This is possible because Ethereum cannot have blind value transfers. So the value has to be made visible to everyone. Objective of this video is to specify various important components of application binary interface involved in interacting with contracts. Now we need to understand that application binary interface is something which can be used in order to interact with the contracts. ABI or application binary interface is strongly typed and it is known at compilation time and it is static. It does not provide any introspection mechanism. So we need to assert that all contracts will have interface definition of any contract they call available only at compile time. This is the reason why smart contracts are stored as bytecode into blockchain and they are specific addresses. These addresses are known as contract address. ABI is needed to access the bytecodes and they take responsibility of defining the functions which can be invoked. They take responsibility of defining the functions that can be invoked. And this guarantees that the functions will return the data in appropriate expected format. And for that, we have concept of function selector. In function selector, you will have first 4 bytes of the call data for a function call specifies the function to be called. So in other words, it provides appropriate format which can be utilized in order to select the function which need to be called. Now, how to interact with contract? We'll have Solidity code, which will be compiled using Solidity compiler, and it may generate bytecode and application binary interface. Bytecode will contain contract instance, whereas application binary interface can be invoked using web3.js. Now, let's take a sample contract. We can define a sample contract. We can specify mapping of that particular data which is private balances to a particular unit. We can define constructor where we can specify balances along with the message that has to be sent to the sender. Then we'll have a getter method to get the balance and we'll have a transfer function which will take responsibility of transferring to a particular address along with the unit of amount that you want to transfer. After writing your contract logic, you have to go and you have to compile. And in order to compile, you can use solc.js, passing name of the .sol file, which is the Solidity file. After compilation, if compilation fails, it will tell you the reason why actually it has failed. You can specify either bin or ABI, depending on your need. If you go with bin, it will generate it in binary format. If you go with ABI, it will generate it in form of application binary interface. Now let's talk about what is the difference when these two units are generated. Bin is compact representation in binary format of the compiled bytecode, whereas ABI is JSON file, which describes how contracts are deployed, what are their different functions of the contract. In case of bin, you have opcodes, which takes responsibility of helping in identifying the operation that need to be executed. They aren't referenced by push, pull, or delegate calls. They are referenced by their binary representations in a text editor. Whereas ABI allows you to have contextualized contract and you can call the functions of the contract by using ABI function format. Objective of this video is to demonstrate the steps which are involved in creating a private Ethereum blockchain. Once you have your system ready, which can be even virtual machine on cloud, or it can be a virtual machine that you can build using VMware or VirtualBox, you need to plan different steps which are required in order to install private Ethereum. There are two components that you need to install here. One is Ethereum and second is Get. So let's start with the installation process. To install, we will be first launching a terminal. In order to launch terminal, we'll press Ctrl Alt followed by T. You'll find that terminal gets launched and it is there in your home directory. To confirm your directory, you'll go and you'll write pwd, which tells that you are in home Skillsoft. Now we need to start planning installation of Ethereum and Get. To do that, we'll install software properties common in Ubuntu. And to do that, we'll write sudo followed by apt-get followed by install. And we'll first install software common properties because it may have certain dependencies which are required by Ethereum and Get. So we'll write here properties followed by common. And we'll press enter. Once we'll press enter, it may prompt you for password. Specify the password and press enter. If you get a message saying software properties common is already the newest version, it means that it is already installed. Else it will complete the installation process. Our next objective is to add repository of Ethereum to our Ubuntu. To do that, we'll write sudo followed by add apt repository followed by -y and the repository name, which is ppa, followed by Ethereum /Ethereum, and we'll press enter. Once we'll press enter, it will try to locate Ethereum and it will try to add it to your existing Ubuntu repository. You should ensure that you are getting a message saying OK. Once you get message saying OK, it means that it has added it to your repository. We'll clear screen by writing clear screen and we'll press enter. Now once we are there at top, we need to pull Ethereum from the repository so that it is ready for install. And to do that, we'll be using sudo. We'll ensure that we are writing sudo apt get update. Once we write this and press enter, it will locate all the repository and it will pull in the dependencies for those softwares which we want to install using our current repository. We'll press enter. Once we'll press enter, it will go and it will get all the packages which are required. We'll wait for this update to get over. Now, once you have your update completed, we can clear screen again and we can plan installation of Ethereum. To do that, we'll be using sudo followed by apt-get followed by install, and we'll specify the name called Ethereum to install it. We'll press enter. Once we'll press enter, it will go and get location from repository and it will try to install it. You need to press Y to continue with the installation. Once it is installed, we will clear screen and we'll see whether tools are installed or not. To test the tools installation, we'll go and we'll write DETH and we'll press enter. Once we'll press enter, you'll find that it starts P2P network at different ports and also listeners. So it means that Get is installed successfully. We'll press Ctrl C to terminate. Once it is terminated, we'll go and we'll test other tool whether that tool is installed or not. For that, first we will clear screen and then we will write Puppet. And we'll press enter. Once we'll press enter, you'll find that it gives you a welcome message saying, welcome to Puppet, your Ethereum private network manager is ready. Once these two tools are tested, it means that your Ethereum is ready and you can start setting up your private network. Objective of this video is to demonstrate how to create a private Ethereum blockchain network. In order to create a private Ethereum blockchain network, we need to ensure that first we will launch our terminal by pressing Ctrl-Alt-T all together. Once terminal is launched, we'll verify whether required tools are installed or not. To ensure that we are able to test that required tools are installed, we will be generating certain accounts. Let's generate two accounts. First one will be authority account and the second one will be pre-funded account, which can be used to send transaction to the network. To do that, we'll be using tool called get. So we'll write get followed by data dir. You can specify name of the directory where you want to store. If we want to store in the current directory, we can write dot followed by Ethereum. We can specify dot Ethereum slash and use account as the command and specify new. We'll press enter. Your account would need a password. So specify your password and ensure that you are not forgetting this password. We'll specify the password and then we'll repeat the password. Both need to match and you will get an address generated. Once this address is generated, we'll generate another address which will be a pre-funded account. To do that, we'll go and we'll write get. We'll repeat the command and it's the same command which will be repeated again. We'll press enter. Again, we have to give a passphrase to it. We'll specify. Passphrase is also called as password. We'll press enter and repeat it. So now we have two addresses which are generated. Ensure that you keep track of password or whatever you have used in order to create these two accounts. Our next objective is to go and create a block. In order to create a block, we'll be using a tool called Puppet. Before we start using that tool, we'll clear screen. And now we will go and we'll write Puppet to get the console. Once we press enter, it gives us the console where actually we can go and we can create our block. Now you have to decide that what kind of block you want to create, whether it is proof of authority or proof of work. We'll go and we'll write CLIQUE as a command and we'll press enter. Once we'll press enter, it will ask you certain questions in order to ensure that you are able to create a network. In order to do that, you will be selecting option 2, that is configure new genesis. We'll go and we'll select 2 and press enter. Once you will press enter, it will ask you what consensus engine you want to be used with the current block. We can select 2 here, which is by default also click. So we'll go and we'll select 2. We'll press enter. Now it will ask you how many seconds should block take. By default it is 15. You can keep default values for now. Now which account are allowed to seal? Here you can go and you can specify one of the account that you created. We'll go and we'll use one of the account. We'll copy and we'll try to paste it here. And we'll press enter. Again, we'll press enter and it will ask you which account should be pre-funded. You can select one of them to be pre-funded. So since we have selected second one as our mandatory account that need to be sealed, so we'll make this as pre-funded. We'll copy this We'll come down and we'll paste it here. We'll press enter. After pressing enter, we'll press enter again, and now it will ask you specify your chain or network ID if you want an explicit one. Default is random, but we can go and we can specify our ID. For example, I'll say 52 and we'll press enter. Once you have done that, you will get a message saying that your Genesis block is configured. And it will ask you the next question. Now you can go and manage existing Genesis blocks if you want to, or you can track new remote server, or you can deploy network components. So we can go and we can select 2 as of now, manage existing Genesis, and you can work on the existing Genesis, like modify existing fork rules or export Genesis configuration or remove Genesis configuration. Whatever you want to do, you can specify your option here. Let's go and export Genesis configuration by specifying 2. Now it will ask you which file to save the Genesis into. So by default, it is click.json. You can specify name of your choice. For example, I'll say genesis.json and we'll press enter. Once you'll press enter, it will tell you that it has exported existing Genesis block. So we have used the generated account, which was second one to work as authority and the first one to work as pre-funded account. For the network or chain ID, we have taken a value. For us, value is 52. Ensure that value is below 1000. Once you have executed all these commands, you have your network setup done. Objective of this video is to list essential capabilities of multi-chain that we can use to build blockchain applications. Whenever we want to benefit organizations with blockchain, one of the quick deployment that we can do is by using multi-chain. In short, multi-chain can help organizations to quickly build and deploy blockchain application. It is a platform that helps users to establish private blockchain of their own. Organization can use it to facilitate financial transactions depending on the domain. And benefit of multi-chain blockchain implementation is it is quick to install, provides rapid deployment features. Apart from that, it also provides simple API to access and various command line interface commands which can be used in order to quickly handle the assets. Not only that, it provides assistance to preserve and set up chain. Multi-chain technology also comes with unique feature of data streams where you can create multiple key values, time series, identification of database on a particular blockchain. So in short, you can go with multi-chain if you are planning to have data sharing, time stamping, encrypting and archiving. You want to have multi-asset, you want to save multi-assets, and also want to provide multi-party atomic exchange transactions. In those cases, multi-chain can be one of the solutions which can be adopted. What are the benefits of multi-chain? Rapid deployment, quick accessibility by organizations to have their own private blockchain. You can create unlimited assets, and yes, you can get benefit of data streaming. By implementing data streams, you can go and you can have identity database on blockchain. Apart from this, it also works with fine-grained permissions where you can control who is connecting, sending and receiving the transaction. You can also control permissions for creating assets, streams and block, where you can go and you can utilize blockchain as an open or as a closed environment depending on the permissions that you are going to apply. So what is the primary objective of multi-chain? Primary objective of multi-chain is to enable visibility of internal blockchain activity, control transaction permissions, and provide a secure mining environment utilizing algorithms like proof of work and associated costs. Not only that, it also stores transactions which are related to various participants who are sharing assets by transferring or receiving various asset ingredients. Now, one of the important task of multi-chain is to have handshake. So for example, you can have multiple nodes where you can have those nodes connecting to each other in order to implement a chain. In order to have that handshake done on each node, you need to ensure that you are presenting its identity as a public address on the permitted list. You are also verifying the other's address in their own permitted list catalog. You are sending the challenge message to other node, and once that challenge is accepted, it sends back a signature providing their ownership of the private key, which corresponds to the public address. Apart from this, once it is done, peer-to-peer connection will be aborted in case if there is no satisfying outcome or result provided by other coordinating node. Mining is essential in order to ensure that verification process is strict, and multi-chain restricts miners to a set of identifiable entities. It also introduces a new parameter called as mining diversity, which contains values from 0 to 1. In order to ensure validity of a block, it is verified by following a particular mechanism like applying permission changes defined by transaction in the block, counting total number of permitted miners defined after change has occurred in the block, and then multiplying the number of miners by using miner diversity factor. And once all these things are done, you have to round up to get the left spacing. Now, what are the techniques which can be used in mining? Most popular technique is round robin, and all activities and configuration is stored in params.dat, from where you can go and you can manipulate mining. For example, you have change protocol, then target time, mining diversity if you want to set, mining reward if you want to allocate, maximum block size, maximum number of metadata passed per transaction, and active permission types. So by manipulating all these parameters, you will be able to set up multi-chain in proper way in a short time. Now let's discuss about some of the limitations which multi-chain has. Unfortunately, multi-chain as of now does not have multi-signature address support and transactions. Adding metadata to permissions or asset transaction is also not supported. Apart from this, looking at the addresses transaction is also not possible. You cannot subscribe to an asset and view the transaction of that asset. You cannot view a list of key or publishers in a particular stream. Multi-chain also does not provide proper support to peer-to-peer node management or message signing and verification. So depending on the trade-off, you can decide whether you can go with multi-chain implementation for your current scenario or not. Objective of this video is to demonstrate various steps which are involved in installation of multi-chain. Multi-chain is one of the implementations of blockchain, and it provides you certain capabilities which makes it popular. For example, some of the capabilities are rapid deployment, unlimited assets. You can issue millions of assets on blockchain, and all tracked and verified at the network level itself. Then you have data stream. You can create multiple key value, time series, or identity databases on a blockchain. And finally, it is fine-grained permission, where you can connect, send, and receive transactions, create assets, streams, and blocks, and all that can be done using proper control. In order to install multi-chain, we need to have operating system and also certain prerequisites which are needed in order to install multi-chain. You can have more than 1, 2, 3 different Ubuntu or even Microsoft Windows boxes where you can plan and install. We are going to demonstrate installation on Ubuntu. Once we will launch Ubuntu, it will ask us the password. We have to go and we have to specify the password. Username is Skillsoft. We'll specify the password as whatever password we have given while installation of this particular virtual machine. Once it is installed, you will ensure that you have updated all the softwares, and to do that you will be launching a terminal. To launch a terminal, you can press Ctrl-Alt-T all together and you'll find that a terminal is launched. Once terminal is launched, let me close the previous terminal first. Once terminal is launched, you can go and you can install all the updates. So to do that, you'll be writing sudo apt-get update and you'll press enter. Once you'll press enter, it will ask you credentials. You can go and specify the password and you'll press enter. Once you'll press enter, it will connect to Ubuntu repository and it will ensure that whatever updates are needed, they are downloaded to make your operating system up to date. Once it is updated, you need to clear the screen so that you can start doing installation of multi-chain on your current Ubuntu box. To do that, you'll be writing clear screen. Next is to go to temp directory where we can download the installer. To do that, we'll be writing cd followed by temp. Once we are in temp directory, we'll be using wget in order to fetch multi-chain. To fetch, we'll be using sudo followed by wget. And we have to specify IP where multi-chain download is available. We'll write http www.multichain.com download followed by multichain 1.0, and we'll be using alpha 21.tar.zz, and we'll press enter. Once we'll press enter, it will connect to that particular IP which we have specified and it will get us the tar.zz file. We'll wait for download to get over. Once it is downloaded, we'll extract it by using tar utility. In order to do that, first we'll clear the screen. We'll write ls to check that it's downloaded, and you'll find that it has downloaded here multichain 1.0 alpha.tar.zz. Once it is downloaded, we'll go and we will extract it by using tar followed by xvzf followed by the name, that is multichain 1.0 alpha-21.tar.zz, and we'll press enter. Once we'll press enter, it will extract. Once it extracts, we'll move to the directory which is multichain 1.0 alpha 21. We'll be there in that particular directory by writing cd multichain 1.0 alpha 21. We'll clear screen. After clearing screen, we'll go and we'll write ls to see the directory structure. And you'll find here 4 important components. One is multichain CLI, second is multichain D, daemon, third is multichain util, and fourth one is readme.txt. Now we'll plan to move this to a location so that it can be called from anywhere. And to do that, we'll be using sudo followed by mv multichain CLI followed by multichain D followed by multichain util. And these 3 files we will move to usr local bin. usr local bin, and we'll press enter. Once we'll press enter, we'll find that we have moved the required executables to bin folder of usr local. You can do this installation on other machines as well. For example, you can have more than one virtual machine, and on that virtual machine you can go and you can do the same installation. Later you can join these two in order to create a multi-chain. Objective of this video is to create and work with multi-chain. In order to create a multi-chain or in order to create a blockchain using multi-chain, we need to ensure that we have installed multi-chain. To test whether it is installed or not, we will launch the terminal. To launch terminal, we'll press Ctrl-Alt-T all together, and we'll find that it launches a terminal. Once it launches a terminal, you need to ensure that you are having all the executables of multi-chain, and that ensures that you have installed it. To do that, you can go to a directory called cd usr local bin. and you can do ls. Once you will do ls, you'll find that multi-chain executables are there. It means multi-chain is installed successfully. Once multi-chain is installed successfully on your terminal or on multiple terminals, you would like to create a blockchain. To create a blockchain, you will be using multi-chain util command. This helps us to create a blockchain. For example, let's create a blockchain. We'll write here multi-chain followed by util, and we have to specify here create. After writing create, you have to give a name to your blockchain. So we'll write here Skillsoft chain 1 and we'll press enter. Once we'll press enter, it displays a message saying that multi-chain utilities build 21 protocols, and it tells that blockchain parameter set was successful. Now, in order to customize it, we need to go and we need to edit a file. And name of that file is param.dat. In order to do that, we'll first go and visualize different parameters, and we'll try to set those parameters as per our need. We will clear screen. After clear screen, we'll go and we will write sudo gedit is the editor which comes along with Ubuntu. You can also use VI editor and specify home directory followed by multi-chain, and in this we have Skillsoft chain 1 and we have the file called as params.dat. We'll press enter. It will prompt for password. We'll specify the password and we'll press enter. Once you'll press enter, it will launch params.dat, which is the main and the important file for configuring blockchain using multi-chain. So we can see certain parameters here which tells protocol version, then some of the basic chain parameters like chain protocol, and chain protocol is multi-chain or Bitcoin. Then you have chain description. You have Coinbase max, which is 256 characters. Then you have chain is testnet false. And then you have certain permissions also which you can specify. So you can tune these parameters as per your need. You have consensus requirement where setup first block equal to 60. So this is nothing but length of initial setup phase in block where it's mining diversity. Then you have mining diversity equal to 0.3. Then you have admin perm 01. This is for admin consensus activate. So you have native blockchain currency details as well. So depending on your need, you can go and you can change the settings. After you have made changes to the settings, you need to ensure that you have some of the parameters known to you. For example, you have default network port, which is 6757. This is the default port for peer-to-peer connection. At this particular port, there will be connection among different chains. Then you have default RPC port as well. This RPC port is used in order to process incoming JSON RPC API request. Then you have name of the chain, that is Skillsoft chain 1. You have version. You have private key version. And you have various other keys which are set to null as of now. So once you are aware about configuration parameters of multi-chain and you are aware about your need, you can go and you can set it up. After setting it up, you can save it and you can close it. Once you have closed, you are there at bin again. We'll clear screen. Now, after clearing screen, since we have already created our blockchain, we'll go and we'll initialize the blockchain. To initialize the blockchain, we'll be using multi-chain D, that is daemon, specify name of the chain, which is Skillsoft chain 1, and we'll be specifying a parameter called as daemon. To do that, we'll be writing multi-chain D, specify name of the chain, that is Skillsoft chain 1, and specify the argument called as daemon. Once you specify daemon, you have to go and you have to press enter. Once you'll press enter, it will start multi-chain server. It will look for Genesis block. And now new users can connect to this node. In order to connect to this node, it has specified the IP as well as the port at which the new user has to connect. It is Skillsoft chain 1 at the rate 10.0.2.15:6757. Now anyone who wants to connect to this particular blockchain, for example, if you have another Ubuntu and someone wants to connect to this particular chain, they can do that by using the command which is specified here. That is multi-chain ID, Skillsoft chain 1, and specify the right IP and the port. So we'll just go and specify here on the same one. If you see, it was not able to connect because it's already running. So we need to ensure that we are doing peer-to-peer connection by creating another virtual machine or by doing installation of multi-chain on other machines and then making call to this command. So be aware, this command will be invoked from another instance of multi-chain installation. We'll clear screen for now. After clearing screen, we'll go and we'll try to test the interactive mode, that is CLI of chain, so that you can use certain useful commands. To do that, we'll be writing multi-chain followed by CLI, and we have to specify name of the blockchain, that is Skillsoft chain 1, and we'll press enter. As soon as you'll press enter, you see it will move to interactive mode. Once you are there at interactive mode, you can execute commands like getinfo. For example, I'll write here getinfo and I'll press enter. Once you write getinfo and press enter, it will display details of the current chain. You can know what is the burn address. You can also know the node address. This can be passed on to other nodes who wants to join to this particular blockchain. Now, in order to explore other commands which are there, you can write help and press enter, and it will display you list of all different functions which are available from this particular CLI, which is invoked using multi-chain CLI. So you can go and get new address, you can get balance, you can get asset balance, you can grant, you can also import addresses, you can import private keys, you can even import wallet. You can also invoke specific help commands. For example, if I want to know more details about send asset from, we'll go and we'll write help, and we can specify here send asset from, and we'll press enter. It displays the detail of only this particular command, where it explains what is the argument and what all are required in order to meet the need of this argument. So you have from address, to address, you have asset identifier, you have asset quantity, you have native amount, which is numeric and it's the native currency that need to be sent. Then you have default, which is minimum per output. You have comment, and you have details of wallet. You can also specify comment to, and you have an example command which you can see here, which can be executed in order to send asset. Objective of this video is to demonstrate how to create assets in multi-chain. In order to work with assets, we have to go and first launch a terminal. To launch terminal, we'll press Ctrl-Alt-T. Once terminal is launched, we need to ensure that we are moving into multi-chain CLI. To do that, we'll be writing multi-chain CLI followed by name of the multi-chain that you created. We created multi-chain called as Skillsoft chain 1, and we'll press enter. Now we are connected to multi-chain whose name is Skillsoft chain 1, and it launches interactive shell, and that shell is Skillsoft chain 1. The first thing that we need to go and check is permissions. To check permissions, we'll be writing list permissions and we'll press enter. It displays what all permissions we have. And if you see, we have permission of receiving as well as issuing assets. You have connect and you have send permission as well. We can go and we can check other permissions. We have activate permissions, we have admin permissions, and we have mining permissions as well. So we have all the permissions which are required in order to work with assets. Now let's go and create a new address in the wallet. To do that, we'll be writing get new address and we'll press enter. Once we'll press enter, similar to Bitcoin, we'll get an address. So it displays an address to us. We can go and we can list all the addresses which are created so far. We can go and we can write get addresses. And we can press enter. Once we'll press enter, it gives us all the addresses which are available. So now we can see there are two addresses. The first one is the new one, which we have created using get new address. And the second one is the address which we saw earlier when we were working with permissions. We can go and we can get now parameters of the current blockchain, which will be typically present in params.dat file. So we'll go and we'll write get blockchain params and you'll press enter. Once you'll press enter, you'll get the details of your current blockchain. This is in order to ensure that you are aware about your current blockchain environment, from where you have to go and you have to create and issue new assets. Now we need to also know a list of connected peers. So as of now, we are running on a single box. In case if you have multiple systems, you can just go and write get peer info and press enter. And you will get a list of all the connected peers here. So in production environment where you have multiple different installations of multi-chain and where they have joined using peer-to-peer approach, you'll find a list of peers and their addresses here. Now let's go and create a new asset. In order to create a new asset, you can get the address that has the permissions to create asset. So we'll just go and use a command in order to see which address has permissions to create assets. And to do that, we'll write list permissions issue and we'll press enter. Now you will get the address which has capability of creating an asset. Once you have the address, you can go ahead and you can use a command to create an asset. Command is issue. We'll write here issue. And you need to ensure that you are copying the address and you are using the same address which you have revealed using list permissions issue. And we'll paste it here. After pasting, we can go and we can give a name to the asset. For example, we'll write asset 100. And you can also go and you can specify the amount. So for example, we'll go and we'll specify the amount. For that, we need to ensure that we are creating units where unit can be subdivided into multiple parts. Here we'll take an example of dividing it into 100 parts and then it will be sent to the current server itself. To do that, we'll specify the unit, that is 1000 units, and we'll specify the parts, which is in 100. So we are specifying here 0.01 and we'll press enter. Once we'll press enter, we'll find that asset is created and you will get the new asset address. Now we can go and we can try looking at the assets that are there. We'll write here list assets and we'll press enter. So you'll find that you have the asset now which was created and ID of that asset is similar to issue ID which was displayed while creating the asset. You have multiple of 100 units that is allocated is 0.01 and you have issue quantity which is 1000. Now we can go and check asset balance. So once you will transfer asset, probably you need to see the current balance as well. To know the balance, we'll write here get total balances, and we'll press enter. And you'll find here what is the total balance, which is there for the asset whose name is asset 100. Objective of this video is to work with round robin consensus, and this comes into picture when you have multi-node installed. Depending on the blockchain technology that you have adopted, you can go and you can see impact of round robin consensus which is built among different nodes. We'll just launch our Ubuntu. In order to evaluate consensus, we can take any blockchain implementation. For example, we are taking up here Bitcoin. So whenever you have several nodes on the network, all those nodes must have blocks which are locally validated and they are common. So there are various consensus rules that need to be followed by nodes in order to ensure that all are in sync. For example, if I launch here my Bitcoin by going through applications, internet, and then Bitcoin Core, which is the current Bitcoin implementation that we have taken, it will load the block index and it will ensure that all different nodes which are part of the Bitcoin implementation have common validated values. So we'll wait for it to load the block, verify the block. And if you see now, it is trying to balance, and depending on the nodes which are not yet balanced, it will go and it will try to balance those nodes with all the transactions which has been done on various other nodes. So there are certain consensus rules that need to be followed that allows node to maintain consensus among themselves. So we need to understand that there are certain decisions which need to be taken as part of reaching to consensus. There are protocols. Because blockchain is a decentralized peer-to-peer system with no central authority, consensus becomes important. That how these decisions are made and how anything need to be done. And this is done by adopting consensus decision making in group decision making process, where all different members have to agree to support a decision in the best interest of the whole. In simple terms, consensus which need to be arrived is a dynamic way of reaching agreement within a group. So depending on number of nodes which are there, whenever you are doing transactions like send or receive, or you're going and seeing the transaction, you should be ensured that it's the same value which is being distributed across different network. It may take some time to balance and to achieve the consensus, but that is what is considered as the best case. Now, there are various patterns and frameworks which can be used in order to have a collaborative, cooperative, and inclusive consensus management. So we need to remember that whenever there is a transaction which is invoked, which can be on any blockchain implementation, consensus within the network and consensus among different nodes of that network is important. And this feature is implicitly built, which can be configured depending on the implementation that you are using. Objective of this video is to illustrate steps involved in installing Multichain Explorer and work with Multichain Explorer. In order to install Multichain Explorer, which is one of the tools which takes responsibility of reading multi-chain block file, transforms and loads that into database, and then provides a web interface which is similar to Bitcoin in order to manage your multi-chain. We need to first log into our system. For example, username is Skillsoft. We'll log in by writing the password and we'll press enter. Once we'll press enter, it will log in and it will provide us capability of installing the component. First, we'll close the existing terminals which are there, and then we will launch a new terminal. To launch a new terminal, we'll press Ctrl, Alt, and T. Ensure that all three you are pressing together. Once your terminal is launched, you have to go and you have to start installation of some of the prerequisites which are needed in order to run and finally work with Explorer. First important prerequisite is SQLite, which provides database capabilities. In order to install it, we'll be writing sudo apt-get install, and we'll specify SQLite. version is 3, and you have to ensure that you are installing the dev version. So you'll write sudo apt-get install sqlite 3 lib sqlite 3 dev, and you'll press enter. Once you'll press enter, it will ask you the credentials. You have to enter the credentials and you have to press enter. Once you'll press enter, it will try to fetch the package connecting to the repository. Now, once you have SQLite setup done, our second dependency is Python. We'll go and we'll install Python dev and Python pip. To do that, we'll write sudo apt-get install followed by Python dev. It will connect to repository and it will fetch, and it will ask you to continue. You'll say Y and enter. It starts fetching Python dev. In case if there is a failure, it may be because of too much of traffic on archive or your own internet connection. For that, you have to go and clear screen and try the command again. Press Y and press enter. Once you have installed Python dev, our next dependency is Python pip. To install it, we'll write sudo. We'll go to the prompt and we'll write sudo followed by apt-get install, and we'll write Python pip. We'll press enter. We'll specify the password and we'll wait for install to get over. We have to specify Y when it is asking, do you want to continue? And we'll wait for installation to get over. Once we have installed Python pip, we need to upgrade pip so that we get the recent version. We'll do it by writing sudo followed by pip install and use upgrade as an option and specify what you want to upgrade. Now finally, it gives a message saying that we are using the current version which is upgraded. Once we have upgraded, we'll go and we'll clear screen. After clearing screen, our objective will be to go and clone Multi-Chain Explorer. And to do that, we'll be using git. In order to use git, first we'll test whether it's installed or not. We'll write git. Now since git is not installed, we will go and we will install it. To install git, we will write sudo apt-get install git. In case if there are some typos, you can write sudo apt-get install git and press enter. Say Y and press enter. Once git is installed, we'll go and we'll write git to test it. We'll just press enter and you'll find that it is ready to be used. First task that we will do is we will create a clone of Multi-Chain Explorer. To do that, we'll write git clone and we'll specify the URL. We'll write https multichain-explorer.git and we'll press enter. It will start creating the clone. Once we have cloned, we will check whether directory is created or not. To do that, we'll first do ls and we'll press enter. And we'll find that it has created a directory called Multi-Chain Explorer. Now we'll clear screen by writing clear screen at the prompt. Now we have to install one more dependency, and that is PyCrypto. In order to do that, we'll be using sudo pip install PyCrypto and we'll press enter. It goes and it downloads from the repository. Now once you get message saying successfully installed, we'll clear screen to move to top. We'll move to the directory which we have cloned, Multi-Chain Explorer, and we'll see the content of this directory by doing ls. And you'll find a file called as setup.py. This is the file which we have to run in order to install Multi-Chain Explorer. In order to install, we'll use sudo python and setup.py followed by install command, and we'll press enter. Once we'll press enter, it will start writing and you'll find that it has executed running install egginfo and it is finally installed. We'll clear screen. We'll do ls, we'll write ls, and we'll find that there is a directory called build which is created. This confirms that your Multi-Chain Explorer is installed. Next, you have to go and you have to configure your Multi-Chain Explorer. In order to configure, you can go and you can first create a multi-chain, or you can use existing multi-chain. For example, we'll create a multi-chain. We'll move to home and we'll write multi-chain util followed by create, and we'll write here test chain 1. We'll press enter. And now you'll find that blockchain parameter was successfully generated. Now our next objective is to generate blockchain. To generate blockchain, we'll be writing multi-chain D followed by test chain 1 followed by minus Yeoman. So you will have now a port which will be allocated to your test chain 1. Once it is allocated, you can go and you can move to the directory and you can visualize param.dat file. In order to ensure that we are able to configure Explorer, we'll again move to the directory which is Multi-Chain Explorer, and we'll be copying conf file. For example, we'll write ls here. We'll find here chain1.example.conf. This particular file has to be replaced with testchain1.conf. In order to do that, we can write cp chain1.example.conf, and we can move to the particular folder and we can create test chain1.conf. So we are copying chain1example.conf to testchain1.conf. We'll press enter. Now we'll do ls and we'll find that we have testchain1.conf file ready. So once you have created this, it means that your Explorer is set, installed, and ready to use. Now it's time to test your knowledge and understanding of what we have learned in this course. In this exercise, you will create a new address in wallet, create a new asset, and then list and verify asset. Now I want you to pause this video and attempt all of the exercises and then come back to view the solution so you understand how well you have attempted. In order to create a new address, first you need to log in your operating system where you have your multi-chain installed. To do that, you will be specifying the password. After you specify the password, you will be on the desktop of your operating system, which is Ubuntu in our case. You'll press Ctrl Alt T in order to launch the terminal. Once terminal is launched, you will go and you will first create an address. To create an address, you need to first launch multi-chain CLI. So we'll be writing here multi-chain CLI, and we'll specify Skillsoft chain 1. We'll press enter. Once we'll press enter, we'll move into interactive mode. Once we are in interactive mode, we'll go and we will use the command called as get new address. We'll press enter. Once you'll press enter, you'll find that a new address is generated, which starts with 1W. Once you have generated new address, you'll go and you will first list permissions to create a new asset. So we'll write here command called list permissions issue, and you'll press enter. You'll get the address. Now you need to go and you need to create an asset using the address. To create the asset, you'll be using command called issue followed by the address. So we'll copy the address from here, which is outcome of the previous command, and we'll paste it. After pasting, we'll go and we'll specify name of the asset, which is asset2, specify the range and also the percentage, which is 0.01. So now what we have done is we have specified 20,000 as unit and we have divided it into 100 parts. We'll press enter and we'll find that it creates a new asset. Now we can go and we can list asset and we can verify. To do that, we'll write list assets, press enter, and you'll find your new asset called asset2 created with multiples of 100 and total unit is 20,000. Objective of this video is to describe the essential security features that we need to implement in blockchain. Some of the major blockchain challenges are scalability, where we need to plan how actually we'll scale up the system because it is distributed component and distributed network and it contains various different components which need scalability. Probably we can have a plan for that. Security is always a major concern because blockchain has committed itself to deal with various domains where security and compliance is primary challenge. So we need to ensure that we are selecting a blockchain implementation which provides sustainable and appropriate security for those domains. Sustainability of the technology is again a question that has been raised by many organizations. Blockchain has been evolving and it has adapted itself with the recent challenges which industry is facing, and it has proved a technology which is going to be there in long run. Now let's discuss on blockchain security. Blockchain has adopted CIA security model. CIA stands for confidentiality, integrity, and availability. We need to think about different levels of implementing security. There are two different perspectives of security implementation. First one is system and second is data. So how we are going to secure our system from external threats and how we are going to keep our data secure. That is what is the prime concern, and in order to implement right level of security, CIA model is adopted. Security model which can also be applied on blockchain is AAA, that is authenticate, authorize and audit. So by using combination of CIA and AAA, we'll be able to have a blockchain application which is secured from all different kind of injections and threats. Now let's discuss on CIA. It works on principle of shared responsibility, where when we talk about confidentiality, it is how to make network access secure and confidential. How data access can be secure. and how to adopt disclosure principle in order to ensure that confidentiality is maintained. Integrity plays important role because data in motion or data of transaction should never be changed. And to do that, blockchain has adopted immutability concept where nothing changes after it is written. Right to be forgotten, traceability, smart contracts, and data quality. These all are used in order to enable right integrity checks, which are required to ensure that transactions are never tampered. Availability is must because we will be going through multiple network and transactions may involve multiple parties. So we need to ensure that we have adopted an architecture which is always available and there is no single point of failure. This is one of the reasons why blockchain adopted peer-to-peer network. We also need to ensure that it is available, operational. In order to implement well distribution of data across network, we can adopt sharding and distributed principles. Now let's talk about cyber risk program. We need to ensure that we are adopting right strategy and governance. And primary focus should be to ensure that our environment is secure, vigilant, and resilient to adapt to any threat that may pose a challenge to blockchain implementation. Now we need to identify what all components need to be secured, and for that we need to adopt layered approach. We can have layered architecture of blockchain system, and then we have to plan how security will be implemented at each layer. Crypto layer, what kind of signatures we need to use, how to secure our platform using platform specific capabilities. What about application security and concept layer? All these layers must be secured using right mechanism, whether it is encryption or it is password based or it is key based. We need to ensure that security is implemented at each and every layer. The objective of this video is to recall the password and key management capabilities afforded by blockchain. Authentication is an essential tool that can be used in order to secure your system from unauthenticated users. There are various different ways in which we can implement authentication. One is password based, where you specify a password which should be strong enough to be tempered or to be disclosed to anyone. Private key based is what is one of the better approach of using authentication, where we have private public keys and these keys takes responsibility of authenticating. Now let's discuss about some challenges which are involved with public private key management. First one is role and terminologies used in public and private key is confusing for new developers. We need to understand how actually these public keys are generated and they are used by other users. We need to also ensure that it is kept secured with other users. Third, migration between devices can be difficult if we are going with public and private key. Now, how to manage key and what is role of key? Key can be managed in order to protect your password, which can be encrypted and it can be used with wallet. Then we have air-grabbed key storage. We have offline storage of the keys. Then we have key which can be stored in local storage. And you have hosted wallet and password derived keys. So there are different type of keys. Depending on the need, we'll be creating and implementing those keys for various different purposes. Now, in order to evaluate what blockchain implementation need to be used and what is the kind of security and trust which is provided by various implementations, we need to understand evaluation framework, which will evaluate your implementation on various categories. For example, you can have key in local storage, password protected wallets, offline, air gap, password derived, hosted wallet, cold and hot. Then you can have hosted wallet hybrid as well. Apart from that, cash and online banking. Now, there are various blockchain implementations which supports different types or different categories. For example, Bitcoin Core falls under category of key in local storage and it supports various features like no trusted third party, resilient to password loss, resilient to key churn and immediate access to funds. Password protected wallets where implementation can be multi-bit also have some of the features which are similar to Bitcoin like no trusted third party resistant to physical observation, key churn, and immediate access to funds. But when it comes to offline storage, we can use bit address, and it takes responsibilities of keeping key offline. No trusted third party is involved. It is again resilient to password loss, and it provides cross-device portability. Similarly, when you go with air-gapped storage and password-derived keys, you will have no trusted third party. And in case of password-derived keys, you can also have no new user software and cross-device portability. So these are few features which will help you to identify what implementation fits your domain. Then we have hosted wallets of three types: hot, cold, and hybrid. Coinbase is an example of hot, blockchain is an example of hybrid, and all of them provides different capabilities in terms of features. For example, all three have resilient to password loss, key churn, immediate access to fund, no new user software, and cross-device portability. Finally, coming to cache, this category is malware resistant, keys are kept offline, immediate access to fund, and you can have no user software and cross-device portability. Online banking, again resilient to password loss, key churn, immediate access to fund, no user software, and cross-device portability. So depending on what features you need, you can go and you can identify the category and the right implementation. Now let's evaluate Bitcoin client and its usability. We need to always ensure that users are aware of steps that are required to complete the core task. They should be able to decide how to perform the required steps. They should also know when the core tasks are successfully completed. They should have intuition, and they should be able to recognize, diagnosis, and recover from certain errors. Then you should also ensure that they should not make any error which can be irrecoverable. Users must be comfortable with the language used in interface dialog and documentation, and they should be comfortable with interfaces for extended usage, and also should be aware of application status. So in order to be a smart Bitcoin client, we need to ensure that we are able to have all these usability evaluation done of our existing understanding about Bitcoin as a client. Objective of this video is to identify the essential security paradigms and strategies in blockchain. Blockchain security concerns. There are certain concerns which may be essential to understand, to have proper understanding and understand constraints of implementing blockchain. For example, you don't have any governing body. It all depends on community, and it's community driven. But this can be a huge security concern for many organizations. Blockchain is evolving. This is the reason why there is lack of universally accepted security standards. So there are various different security standards, but acceptance of those security standards is still a challenge. Third, it struggles to adopt security protocol and processes which are evolving. So blockchain need to always ensure that adopts current recent security protocol and processes which are being used to secure applications. Lack of standard is another challenge, where different implementation have their own approach of implementing security. Since there is lack of standard, it may also create interoperability challenges. And this interoperability creates security risk in blockchain adoption, because you need to keep your blockchain open in case if you are looking for interoperability. There are certain security hacks which was experienced in blockchain. For example, nice hash hack, which occurred in December 2017, and it disrupted lots of financial transactions. CoinDash, ICO hack, Krypton and Shift, these were popular and they emerged in early stages, that is August 2016, and lots of blockchain implementation had impact of this. Then Steemit. Finally, the DAO, which occurred in May 2016. But with maturing system and upcoming security implementations in different blockchain implementations, this has been taken care, and probably systems are improving. Now let's understand different threats which are there in blockchain from security perspective. Crypto key itself can be tampered. Blockchain permission escalation is another security threat. If consensus mechanism is not adopted properly, it may be a huge security risk. Lack of blockchain security program plan and integrity may also create lots of security threat in blockchain implementations. Lack of malicious code protection. You need to ensure that you are securing your blockchain code from various different type of injections. Avoid misuse timestamp, Genesis block tampering, and take care of denial of service properly. Apart from this, on network, it can be packet sniffing and MITM attacks also. So you need to ensure that when you're planning your security, all these threats must be taken care. Then there are various security guidelines that we can follow while implementing our blockchain. First one is ensure that you are using a secure infrastructure and your delivery mechanism is also secure. Prefer creating exclusive risk management framework for a speedy blockchain security implementation. Try to adopt solutions which can take care of identity management, business, and things. Always conduct security assessment and have your rating for the system ready. Identify some of the challenges where you cannot compromise and try to ensure that you are adopting those security mitigation schemes in order to secure your blockchain infrastructure. Follow the approach and solution methodologies which are always created by security experts. So don't always depend on existing developers, but try to take various security experts, their advices, and different methodologies which are projected by them to secure your implementation. Now, in order to understand what all different security levels are there in blockchain, we can start with securing transactions. Account security becomes essential. Then programming also need to be secure from data injection and changes which can be injected in the code also. Distributed organizations, where you have multiple organizations participating and using public blockchain. Network must be secure by using right encryption mechanism, and you have to adopt right governance policies in order to ensure that there is no unaccountable activity done by any user. Now, there are various models which has come up in order to secure blockchain. We can divide it into 5 different categories. First one is security design, whose focus is on design, architecture, and bringing in the consensus. Then we have tech audit, which typically deals with payment platforms, nodes, crypto services, and other essential elements which are part of transaction. Regulatory audit, you need to ensure that you are conducting data security regulations and you are having proper audit channels. Security reviews, you need to ensure that right agreement contracts are made between partners and they are reviewed on a frequent basis. Apart from that, also think from perspective of platform and apps and build proper secure consensus network. Then last layer is API and VM review. You need to ensure that you are selecting the right API and SDK which are powered by security, and also you are securing your virtual machines which may behave as one of the nodes in your blockchain network. What best practices we need to adopt when we talk about blockchain security? Always prefer dedicated blockchain security audit practice. Blockchain R&D Hyperledger setup. When you are doing Hyperledger setup, ensure that you are thinking from security perspective. There are certain use cases which you can use like proof of concept. You can go with governance framework, consensus, node audit, risk advisory, solution design, and implementation. All these different use cases must be specified and must be an area of concern when you are implementing blockchain applications. Don't forget to do penetration testing because it helps you to identify security gaps in your infrastructure. And once you have identified security gaps in your infrastructure, you can have a detailed mitigation plan for it. Take advisory service for best practices, typically in area of data and key management, and that can be done through HSMs. Objective of this video is to specify approach of securing nodes and wallets. Nodes and wallets makes essential part of Bitcoin blockchain implementation. You need to always ensure that you are testing node vulnerability as well as wallet vulnerability, and you are doing proper assessment and build review to ensure that they are secure. In order to check out node vulnerability assessment and have a plan to take care of build, you need to ensure that you are doing redundancy testing. Apart from redundancy testing, you also need to ensure that you are doing synchronization testing so that you can ensure that system is in sync. Consensus algorithm testing to check what is the capacity and capability of existing consensus algorithm that you have implemented, whether it meets all the needs of your existing domain implementation or not. Then you have private keys. Generate private keys properly and distribute it across nodes in order to ensure that proper handshake can be done when a particular node is added in a peer network. Have a policy for password strength. It can be combination of various elements. For example, you can have password strength review by ensuring that whatever password is accepted, it contains a mix of various different alphabets, numbers, and special characters. Have a review over key storage. That can be vulnerable in case if storage is not secured properly. Also have a look over your shared ledger, because shared ledger information disclosure may be dangerous. So you need to ensure that if a ledger is there which is distributed and shared, it must have security applied on it to avoid any disclosure. And for that, we need to conduct disclosure checks. Implement smart contracts in order to ensure that communicating partners or partners involved in a particular transaction must have proper agreement in place, and this agreement is a digitized agreement. Always conduct code review in order to identify vulnerability in the code. API testing is another approach using which you can ensure that API injection is not happening. And to do that, we can adopt some standards. So there are various frameworks which are there in order to do API testing. Specifically, if it is a web application or mobile application, you can use OWASP style testing, which includes features like injection, cross-site scripting, broken authentication and session management, cross-site request forgery, security misconfiguration, and insecure cryptographic storage. So ensure that you are conducting API testing using OWASP, which includes all these essential tests. Now, how to secure wallet? In order to secure wallet, we can adopt two-factor authentication. Always set a secure password, and password should be strong. Block TOR IP addresses in order to ensure that your wallet is not open for any security threat. Enable notifications in order to ensure that owner of wallet is aware about what's happening in the wallet, what is the transaction, what is the send and receive amount. Configure automatic email backups to ensure that all the notifications and transactions are historically managed and maintained. Next, follow certain best practices as a user. Be mindful of online services. Small amount for everyday usage. Secure your amount for everyday usage. Always back up your wallet. Encrypt wallet. Don't keep it open for public access. Save your wallet offline so that you are not always connected to internet, reducing online threats. Maintain up-to-date software. Ensure that whatever wallet software you are using, it is up-to-date and it has all the patches applied on it. Try implementing multi-signature for protection against thefts. And consider testaments, which may be an essential tool to secure your wallets. Now, in order to secure wallet, if you take up a case study, a transactional wallet can be secured by using different elements at different interventions. For example, whenever a client sends a transaction request, which can be broadcasted to a P2P network, which contains multiple nodes distributed across network, it should first validate node and the transaction and also check the user status. Once transactions are verified, those transactions will apply cryptocurrency contract, records or other information. And that finally will create a cryptocurrency which has to pass through certain steps. For example, your cryptocurrency has no built-in value that is redeemable for any other commodity like gold. Then you have cryptocurrency exist only in the network, applying another level of security, and network is decentralized and supply is not determined by banks. It is not governed by banks. Apart from that, once you have verified transaction, a new block is created. That block is combination of transaction which will get attached to another transaction after verification. And finally, the new block is added to an existing block and makes it permanent. Once it is made permanent, it cannot be changed. And finally, transaction is successful. So if we see here in blockchain, there are various different steps where security implementation check is being done. Objective of this video is to identify the limitations found in blockchain security along with vulnerabilities associated with hack and denial of service attacks. Blockchain is still evolving and there are various threats which have already created certain insecurity in consumers. Blockchain has been trying hard in order to ensure that it adopts right principles in order to implement better security. Denial of service is one of the concerns which need to be taken care. Denial of service is typically an approach to ensure that service is unavailable. It can be done by creating huge traffic from multiple sources. Distributed denial of service can be classified into two different types of attacks. One is when that attack is on application layer, making your application services unavailable. And second is network layer, when it makes network itself unavailable for connections. There are various motivations because of which distributed denial of service has to be taken up seriously. One is hacktivism, cyber vandalism, extortions, personal rivalry, business competitions, and cyber warfare. These are some of the motivations which may motivate hackers to create distributed denial of service. In order to ensure that distributed denial of service can be prevented, blockchain, specifically Bitcoin, have adopted certain principles. It provides inbuilt protection to deter DOS attack in version 0.70 by not forwarding orphan transactions and blocks, by checking out and striking out double spend transactions. Also, it avoids sending the same block transaction or alert twice to the same peer. Always keeps track of entries and evicts random entry in orphan caches whenever removing an item. It ignores big orphan transactions to avoid send big orphan memory exhaustion attacks. In RPC layer, only send an SSL 403 response if it's not using SSL during proper SSL handshake. Similarly, in RPC, sleeps sometime if the authorization fails to deter brute force short passwords. When it comes to GUI, limit URI length to prevent any DOS attack. Consider non-standard signature script with size which is greater than 500 to avoid any DDoS attack. Non-standard signature scripts that contains operations that are not push. And finally, does not forward or process non-standard transactions. So keep a check on transaction before you forward. Let's follow certain implementation guidelines which are provided by blockchain. Ensure that block sizes are restricted to 1 MB. Also keep an eye on maximum number of signature checks. A transaction input may try to request the maximum number. And also apply limit on the size of script, number of expensive operations, number of key arguments that can be passed to OP underscore check multiple signature. Number of stack elements also need to be limited. Number of signature checks a block may request, limit them as well. So by limiting certain important essential configurations, you will be able to avoid DDoS. Now, there are certain popular DOS attacks which has been done on systems like value overflow incident, Allen Wayne. Then you have Mount Gox. You have the DAO. You have parity wallet freeze when users were not able to transact. Then you have coin check. These are some of the popular attacks which has taken place on blockchain implementations. What threat denial of service offers? You have great chance of stealing a private key. You can have Bitcoin miner malware, which can have impact over your analytics. Stolen value stores. Torsion attacks by transferring. Implementation weaknesses. Weak SSH 256 signatures. Also hack vulnerable sites if that site is not tested properly from security perspective. These are some of the threats which may have impact over your blockchain implementations. Now, how to avoid denial of service attack and preventing systems from hack? You need to monitor traffic. You need to look for abnormalities. You need to always look for unexplained traffic spikes. Identify suspicious IP addresses. Watch for signs of attackers performing dry runs to test defenses. Once you monitor your traffic, you will come to know about some behavior which may help you to detect the attack. Also, try using third-party distributed denial of service testing tool. You can simulate an attack and see how actually you can take care of it. Once you have adopted third-party distributed denial of service testing, you can create a response plan and a rapid response team, which can take care of overcoming any vulnerability which is created because of denial of service attack or hack. Now it's time to test your knowledge and understanding of what we have learned in this course. In this exercise, you will describe blockchain challenges, security standards adopted, and implementation guidelines. Now I want you to pause this video and attempt all of the exercises and then come back to view the solution so you understand how well you have attempted. There are certain specific challenges which blockchain faces today, specifically in terms of scalability, security implementation, and sustainability of the technology. Because blockchain is evolving and there are organizations who are adopting blockchain, they're concerned about scalability, that how actually it will be scalable and how scalable model can be implemented. Security has been concern always in blockchain. Because of lack of standards, it is still a challenge. Sustainability of the technology is a question because there is debate which is going on around blockchain implementation and their capability of managing transactions using distributed ledger. Second important aspect is security standard adopted by blockchain. Blockchain follows model of adopting security. There are two popular models which are adopted. First one is CIA security model, which provides implementation concept of confidentiality, integrity, and availability. Second model is AAA model, which is authentication, authorization, and audit. Blockchain uses various different approach of adopting these two security models in order to gain confidence of the users. There are certain implementation guidelines when we go and implement blockchain. For example, you need to restrict block size to 1 MB. And there are certain limits that you have to specify for various parameters. For example, you need to always set the size of each script, number of expensive operations in a script, also tune number of key arguments, that is opt, check, mult, SIG. Do specify number of stack element that can be stored. Also provide number of signature checks a block may request. And always follow defined best practices depending on implementation that you are using.